These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner all up for you, operate it until it's up to speed, and then when you decide, transfer it over to a partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, expertise and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit.
I start my days, sun rays, I tap the phone, coffee's on, I mow the lawn, impressing Sean, so connected, so effective, I let it drop, clean it up, heated smart, I do my part, get in the car, superstar, they're watching me, IoT, 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 I check my stock, what a shock, buy some prawn, my oven's on, coming home, future zone, all for me, IoT, 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 live like a Bosch, with many connectivity solutions for a smarter future. From Bosch.
DataVard is a global software engineering firm that takes a uniquely human approach to solving problems. With over 20 years of experience, teams of highly trained engineers around the world, deep industry sector knowledge, and ongoing technology research, we help clients create custom software that improves their operations and opens new markets. We integrate our engineering excellence with deeply human values that drive our business and our approach to relationships. Curiosity, empathy, trust, honesty, and intuition.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Hello, it seems that I'm on air. Just a second to be sure that everything is as it should be. So let's share something. Okay, so good morning. It's a nice way of spending the Saturdays, try to learn something new, and spending the time of listening to this presentation. I've seen another track. I have a very let's say, prestigious and well-known competition. Okay, I'm still fighting with this tool. I'm not sure what you are seeing. What I see on YouTube, I see only myself. But it's pretty good because the presentation, as far as it goes, you'll see. So let's first introduce myself. Why I'm here talking to you. I'm Cătălin Gheorghe. I'm solution architect at a company in Romania. We are doing IoT even before IoT had the name. From the year 2011, each year Microsoft awarded me the title of awards me the title of most valuable professional. I'm in two categories. One is Azure, and the other one is Windows development. Anyhow, IoT goes to this part. Also, I'm a holder of the title of Intel Software Innovator. Again, the IoT part. And Microsoft Certified Trainer. Today will be on, let's say, on a journey. The format of the presentation, it's an offline presentation. This could be a great offline presentation, a discussion between us about real time in the Azure context. As a canned YouTube presentation, okay, we'll see how it goes. This is, let's say, a journey, an epic. We start with some problems and we try to solve it. We see what are the stuff. We see what are the solution. We'll try to see some hardware demos and stuff like this working. You'll see the hardware and hopefully you'll see the hardware working. Again, I'm not quite sure what you are seeing of all this, but okay, let's try to explain you the tricks that I have into my my hat, the magician tricks. First, I have this sheet of paper, which is my timeline, which I need to adhere. Second, on the phone, I'm on the YouTube channel that you see. I'm seeing that you you see me talking, as far as I know, but you do not see the slides. Whatever, the slides are not that many. In fact, I will ask the organizer to make them available to you after the presentation. There are some links. Okay. Again, you see me that I'm wearing a headset. The options will be, I like old mics, and will be something like this, or they are very good mics, but the problem is that this is also a server room. So this means that it's a hiss, and also I must say that Mihail, you know him, was very kind and sent me a cat from Bulgaria, and that terror cat it's always destroying something, and also this would hear on the mics. Okay, let's start the talk. We're gonna talk about real time in the context of Azure. It's a bit of misnomer. Why? Okay, if we're thinking about Azure, it's something huge. It can be also equivalent to an operating system. Architecturally, I don't suppose that you can talk about Azure like real-time operating system. This again will work very good if it was an offline presentation. I'm hoping I'm gonna do it soon. Why? Because down below, Azure is a system of queues and events. Queues and events. When I start talking about queues, you are losing the operating system stuff. You are really operating system real time, because you are caching events instead of replying to them right away. What I've discovered, and if you are asking about the response time of the some services, because um, as far as I gathered, all services, they have a guaranteed response time of something. You'll get a defensive answer. I had a defensive term. You'll get something like, there are latencies until the cloud gets and stuff like this. And this is, okay, true. Well, nobody of us is stupid. You know that you're taking into account the time that you get the data to the cloud. But afterwards, there are some response time. They know them. And generally, almost any component in the Azure cloud, it's not computer real time. It's very fast. It's very fast for cloud service. And yes, if you're digging on the internet, they have specified the response times for anything. As far as I gathered, okay, Azure, it's huge. I cannot claim knowledge of all the details. Only not time series inside stream analytics. It's real time at the moment it gets the data. This I discovered in the documentation. Anything else, it's pretty much, very fast, but not computer real time. So essentially, you cannot run a process in the machine doing something and responding to an external event, and that because the system itself, it's not architectured to be real time. We are not talking about latencies. Anyhow, for latencies, you most probably know what would be the solution would be to use Azure Edge, IoT Edge or something, and move the modules that you need to slash latencies there. But still, it's fast, but no cigar. Okay, but we are talking a lot about real-time operating system. At the end of the day, what is that? Just let's try to think about. Okay, I suppose that the one who are getting lost to this presentation had some backgrounds in computer science. So we know that we have some tasks that run in the operating system. The operating system is doing a job of changing between them or starting them as response to events. That each and every operating system is doing so. Going to history, historically, in the time we did start programming, I'm that old, it was Windows 3.1. So there, the task, or we'll talk a bit later about task thread discussion. The task give to the other task when they finish their job. The task themselves, they are doing the moving of the changing of the running task. In the Windows systems, the modern one, the tasks have priorities and they are run by rings. The last time I studied that, how the stuff was working in Windows, you have the ring of priorities going this manner. If I'm starting doing a task of the, let's say, priority 2, until I finish all the tasks on priority 2, I won't move to the next priority, but to lower priority. It's not that intuitive, but it seems to work. Okay, this stuff, it's not the way an real-time operating system is working. Sometimes, if you have a high priority task, you just need to barge in. On this, with the rings, until the task is finished, you won't do the switch. In a real-time operating system, you need to do the switch almost immediately. I will try to share something. Let's see if I I can do it. Okay, let's try to share yet again, because what I'm seeing, yeah, now I'm seeing something. So let's move to anyhow the presentation. There are let's show you the two slides. Besides thanking to the gracious sponsors, let me put again because this being and that's pretty much the presentation. So let's see what I'm sharing. You'll have the link to this white paper from Microsoft. They show you how the stuff works this is a real-time operating system, and this is a normal one. This is how they do it. It's an interesting white paper. This is the link to it. Let me check if I'm sharing this or something. Sharing something. Okay, so getting back to this, in the real-time operating system, also I must be sure that the same operation takes same amount of time when I'm running it again. Not now it's taking 10 milliseconds, and after that it's 20. I need to be sure that when something happens, I will respond to it when it happens, and the operation will take the same amount of time. This is in the layman terms what's all about. Again, we're talking here about Azure Root RTOS. What? Okay, let me fog you a bit more. What's the connection between Azure RTOS and Mars? So I will give you a hint. This is so. This is the hint. Going a bit to the history. Microsoft was always in the field of real-time operating systems, but they had a product which is called Windows Embedded. It started like something running really close to the hardware. It was different from the Windows consumer because it had part of real-time operating system, and there were variants of real-time operating system inside. You have Windows Embedded real-time, some variants of that operating system, and this operating system changed a bit to support phones, the first version, then changed a bit more to support Windows phones and stuff like this. And when it was an idea, the Windows to get unified, and that Windows Embedded was changed even more, and that it's pretty much that was let's say for them a problem, because the big Windows, it's a huge beast, and it's not that real-time friendly. At the end, with the Windows Phone folding down, everything closed. But Microsoft feel the need of this. They needed something on this area, and we're getting to this company, Express Logic. Express Logic was on the field of real-time operating system for quite a long time. You see, even the NASA used them. It's something like Linux-based, and yeah, Microsoft gone shopping, so they bought it. Of course, like everything now and around, it was renamed Azure Real-Time Operating System. So let's see how we are doing. We are pretty very well doing it with the time. Still, my let's say witness screen show you that I'm quite something like 3 minutes behind on the screen. I'm seeing the past. So let's try to see what are the components. I'm still sharing. There are more components because a real-time operating system also by definition should be smaller. You do not want to have something huge, and also should be modular. Today we're going to talk and going to see at work pretty much this one, ThreadX. Okay, here I will do the corollary. Usually you'll see in the first document, you're going to see also on the slides on this one. What are the difference between thread and tasks? So operating system are talking with tasks, but as conventional in Azure RTOS, we're talking about threads. Threads you see more like execution as a batch of instruction that are executed usually to make the user interface more responsive. But in this case, are equivalent to tasks. They are batch of instructions that are executed in the same batch. Sorry, and you want that execution to have always the same duration and stuff like this. Conventional here, thread and task is the same stuff. In the real world, it's not quite, but this is the convention. So we're going to talk about this ThreadX. Usually, the most of the samples you see it around ThreadX, and also here it's the biggest advantage of doing stuff. Usually, when we're talking about an real-time operating system, we're talking about ThreadX, this level. We have FileX. High performance, FAT compatible file system. Again, access to files, stuff like this. We're talking about GUIX. I'm going to show you something. Unfortunately, the more roundup demo on GUIX, it's in the works, especially at Microsoft, because okay, we'll get back to it. What are the problems? What's giving you that? It's giving you a highly responsive graphical user interface. In a real-time operating system, it's not quite what you... on the Mars orbiter, you do not need a real-time user interface, but okay, sometimes you need. And they give you a way of doing it. It's pretty nice. We're gonna spin up the editor and stuff like this. We do not have a roundup demo here. Also, we have network, it's NetX, and NetX Duo for industrial grade TCP/IP. On everything, we have something like a version, even for USB, high performance USB host. There are a lot of components doing this operating system. You see, technically, nothing has a connection with Azure per se. Okay, where it runs, and this is the discussion that we have. Where this stuff is running, we're still wonderful on time. It's running, let's say, on higher-end processors, higher-end. You won't run it on absolutely dirt cheap processors, but the list it's you know, I'm using Wikipedia. The list is pretty big, so let's put it this way: what we are doing hardware, we are using something like 60% of this, what we have around. So pretty much, if you have a spare core, a bit powerful core, you can run it, and it's you have has samples. It's your embedded developers won't get lost running with this, and okay, you have pretty much everything you want. Uh, I would say maybe with the exception of GUIX, because on GUIX you need to write a bit of a driver. Uh, Still, there are not yet examples. I can show you some of the stuff. There are not yet all nice documentation for you to build drivers, but there is documentation. It's not nice. So yeah, everything you have out the tool, you have the drivers, you have it here. And if you are looking here a bit below, you see a bit the timeline. So it's from 1997, ThreadX was started, and 2019 Microsoft bought it. So it's something that it's new in Microsoft portfolio. They are making their own, and you see it. The first they slap in the name Azure. So you'll see if you are looking over the net, you'll see information on how to run on different development boards, and there are a couple of them. Here I make my mea culpa after I started the browser with all the links prepared. I did not run to them, and they are now loading. But as you see, there is a pretty vast array of processor which are this. Okay, they are not the dirt cheap one, but they are the most common one. And you find documentation. You find external documentation. For example, this is for working development board with MX chip. And also you see development. You can do it even in their tools. And again, hardware support. It's a pretty pretty general. You see it running on a lot of stuff, and we're getting, let's say, we are valsing toward the demo. And what we're gonna do the demo. So let me. I'm gonna show you the box first. So if you see it, let me check if you see it. Maximize. It's maximized. Okay, so. I see that is a complaint about the. Let's try to change the definition of the video and try to share again, because it seems that not everything was shared. Okay, let's do shared. Okay, getting back to this, you see it a bit. This is MX chip. This is something that was built to help you, let's say, start developing, especially for Azure. It's a board, has a display, has a couple of sensors, a couple of buttons, a couple of LEDs, and that it's a pretty decent board to start pushing data into Azure. Well, I've seen architecturally, it's not something that my colleagues were impressed, but it's working. I'll say as a teaser, it was an idea before the pandemics that Microsoft should loan me a couple of 10 or 12 devices like this to do labs across the region. Of course, in Bulgaria for sure. And there you see it. Okay, even on this, because you have a spare processor, you can run it. Usually, you develop using Visual Studio Code, but let's say you can run even Azure RTOS on this, and we're gonna run it on this. Let me show you a bit the GitHub repository for samples. So I'm hoping I'm still. The head of the truck told me that you do not see everything on this. Okay, you'll got the links. I'm just showing you something to have some visual cue, because this is a story. This is like radio. You should listen to my voice, and yeah. So you have a GitHub repository which is okay, getting started, and you have it a lot of boards. This is MX chip, microchip, NXP, Renaissance, STP, STM Electronics, a lot of common boards. And if you are doing, I must emphasize, you should do a clone, not a zip. And also be careful that to put it in a place where the link is not too long. It has a problem with links longer than 256. And afterwards, you just run a zip to get the tools. The tools is CMake, and they are using Termite as serial port monitor. Okay, it's not my professional tool. It's far better than Visual Studio Code using for this. And yeah, on the case of MX chip, how the stuff is working. If you ever work with MX chip, when you put it, in fact, let us connect it to the PC. It's a simple cable. You see it here, and if we connect it, you will see if I'm. You'll get here an IAZ folder. If you are putting here a compile bin, at the first reset, you will install this firmware to the device. Okay, what do you need to do on this? Why you need to change the bin? Okay, first, because this is not running RTOS. And second, you need to specify some information into this. These samples work with something called IoT Central. So let's try to explain to what's IoT Central. Microsoft discovered that it's pretty difficult to start an IoT solution in Microsoft components. So for them, because you do not see what to use, there are let's say some companies really want to get started, and the most common stuff that they want to do, it's not that complex. So they made at the beginning two assemblage of the components was Azure IoT Suite and Microsoft IoT Central. On IoT Suite, which it's a bit fade away, you had absolute control. They give you a pre-made solution that you can change everything and anything. It was, let's say, more or less architectural blueprints that you can modify. But okay, on the other hand, was pretty heavy. They are using a pretty heavy concept and pretty expensive components in it. So it wasn't the most popular. The other one is IoT Central, and which you can you have some kind of businesses modeled already, and you can make them your own. You can add your rules. You can add your devices. You have simulated devices. Yeah, you can do a demo in minutes with this. And also for, let's say, a good 40 to 50% of the businesses, it's enough what they give you. And also they take responsibility of the whole infrastructure, what's in IoT Central. So essentially now the main push, besides the components itself, And besides new concept, it's IoT Central. The new concept is the one that, anyhow, Mikhail and I were talking a lot. It's twins. And this, it's something that I recommend you to look. So let me try to show you this one. Let's go to IoT Central. I've created an, in fact, we have the, I've created an Azure Bootcamp Vertos IoT Central. I did not do any big modification into it, besides creating a new device. So this is how you create a device. It could be also simulated device if you do not have a right one. I needed some of the parameters that from here. So let's if we click here. These the parameters from here, the name and the primary key and the ID scope, which I needed to put on the file. In one file, you have everything in the documentation, how to do it. And besides that, you also need internet connection. Also the parameter of the Wi-Fi, because even though it's connected by cable to your PC, it does not share internet connection. You need to have a Wi-Fi. So this you put in the file, you compile the bin, you put the bin, you restart it. When you restart the device, you'll see, I hope that it's cable, it's long enough. I hope that you see that. It's a Azure IoT. Strange enough. Okay. This is because I connected. Usually it says something like SMP initiated. What's this saying? I'm giving you here a hint. Especially these devices have a very strange time server. What's a time server? It's a service for synchronizing time. It's not using the time.microsoft.com Windows. They are using some Linux one, and sometimes they are blocked. Ask yourself, I don't care about the time on this device. Yes, you're right, you do not care. But Azure cares. The question is why Azure cares. It cares about cryptography. If you are not in the right minute, all the cryptographic functions will fail. So again, if you're trying to connect to Azure and you have strange failures, check your time. It doesn't matter the time zone. You need to be in the same minute. So this is why a time server is highly important in connecting to Azure. So if you connect it, let's see what we have here. So now you see it because we connected. You have temperature, which is, yeah, pretty much, because it's on the server, it's something like 30 degrees. You see the sensors from the device. Also, now say Azure IoT knows a lot of stuff. Devices are easy to connect. There are concepts like plug and play, and they advertise the capabilities. There are the classes of devices. So I'll say, as far as I did not need to specify any of this, I did not create any of these graphs. That was from the box. I just registered the device. And you see also the raw data. Okay, you ask yourself, for this I need a real-time operating system. Well, let's work here. Let's try to do accelerometry a bit. Here it's a bit of a delay, and now you do not need. And also I've tried, because I have two devices. I try one to run the software from the box, and just to connect to IoT Central, and this one with Ertos. without a high resolution clock at this level of playing, you won't see any difference. Really. Okay, that's, I must say, here you see when I start the shaking device, the stuff change, and you see a delay. Again, the function itself, when I did this to the device, was in real time, just kicked in. We're going to look a bit in the code, in my favorite code editor for this. Just kicked in, but the delay, the latency, it's in the transmission. So, getting back, with these boards, it's pretty difficult to do a meaningful demo showing the difference between a real-time operating system and a normal operating system. Okay, if I'm running a machine, for sure, I'm gonna see it. Or if I'm running a door, even a door, I'm getting into a company. If I'm doing a round trip, and if I'm not having a real-time operating system, where I will see it. Here, what I'm showing you is that I'm running. You should, okay, have faith in I'm saying that I'm running on this real-time operating system, Azure RTOS, and again, we see this changing. So let me show you something more. Again, on the command part, as Azure goes, we have we can do some things. One is the device twin, which is a subclass of the twins. What's that? It's essentially we are synchronizing a configuration file. And here you have it very well packed. Again, I did not do anything. I just want to, let's say, let's see, which LED will get, we should have a LED doing something. Let's try to run it. Ah, yes, this one. So, what's the system? It's looking if the LED should be on and off in the configuration file. And when it gets time, we will do that. Okay, here I'm just using this command tab to tell you about the twin. Here it's implementing like a method. It's something even more interesting. I can run a method from someplace in Azure. I can run a method on a connected device. Okay, let's do it here as text goes. I hope that you see me. Hello, Sophia. So you see the text. Let me try to explain. So device twins, it's working at the configuration level. This is will remain as long as the device it's registered to this machine. It does not have a timeout. Command will work only if the device is connected, as now, and it has a timeout. Device twin, it's a much more interesting concept if you are moving outside. I strongly recommend Mihail's, or let's say, blowing my own horn, mind presentation about twins, because it's a way of representing the real world in the cloud or someplace. Here, these both changes are implemented with commands. But I'm using the first one. Usually in my demos, the LED state I'm doing with not with commands, I'm doing with twins. So I mentioned this because this is interesting. This is a concept that you should look on. It's a highly interesting concept. Again, as commands go, there is a third way of sending data to the device. If the devices are connected to the IoT hub, you have bidirectional communication. You have also channel of command. Uh, these tab, as far as I know, are direct methods, are not comments, as far as I know. But again, everything was packed up. For this to create, I just said I want a custom IoT Central with the name. I did not do anything, and then I connected the device. So again, also IoT Central, you can take it and make it your own. You can put your logos, you can register your devices, you can put maps, you can change it. And bear in mind that Microsoft is taking care of the whole infrastructure. You also can have rules. You also rules what they are doing if something goes. You a custom rule. For example, if you're monitoring tracks, you have a class of devices that monitor tracks, and the temperature in the back of the truck goes beyond a temperature, you should send mail to the manager or something like this. You can do this. They are open enough, and powerful enough to do your job for a lot of companies. You have analytics, you have a lot of stuff, and all you can run without devices. You have simulated devices. I hate it in the bottom of my heart because simulated devices are not the real thing, but you have it. You can build a demo for your boss in something like 1 day, and it will be, and afterwards, not more than a week, you can go to real production, adding a device, finishing all the touches. Okay. You see that you can connect any operating system. You see here we did an overkill about connecting an IoT an Azure RTOS. And now I'm on the device. Let's see the first message, because I did tell you about it, but I do not see it. Still it's blank. And let's start also termite. Wi-Fi it's ready, it's telling me. So if Wi-Fi is ready, SNTP time server initiated. And this is the operation. And let's see termite. That just to show you, I'll say it's not the tool that we use for monitoring. Oh. And I need to change, because this is why should. So now you start seeing the good messages. If you seem garbled like you seen before, it wasn't the right speed on the serial monitor. Again, it's not the only tool. Here you see the messages. This, it's not done automatically. Somebody wrote in the code all this. But okay, this is how you debug if you are new in the IoT. Usually you're sending messages through a serial port. Okay, this, it's not the only serial port. I'll say this is what you find in the GitHub when you install the tools. They install also termite. Also, Visual Studio Code has this capability, but let's put it this way, this is my personal option. I'm hating passionately Visual Studio Code. It's, if you are getting to here, where we talked about priorities, we're talking that we can have task more priority. Okay, let's start. Let's first see what's in the code. This is the code for. Okay, I can show you also. No, this I won't show you because it was my Wi-Fi password also. The Azure config.hash you need to modify with the connection stuff and stuff like this. How it looks, the main C of the Azure RTOS that we are running now. So we're doing board init. Board init, it's not the task we talked. It's not a task per se. Not a, I'll say thread. We are doing takes kernel enter. This will do. Takes kernel enter. It's something like this. It looks like in Android, you're having a loop, and when something, some messages get in, they will be sent to someplace else. So essentially, to have it in good English and to make sense, it's when I have an sense of sending that I have data, I will interrupt what I'm doing and send it over to the cloud, but again, without doing anything stupid. Here is the real definition of the telemetry messages. You see it's having NX, IoT, all these messages. Let's look in the documentation how we change really these priorities. These are a lot of these methods of changing priorities, of creating semaphores. If you are knowing a bit your old operating system, you'll be able to not old operating system components and stuff. You'll be able to get it. You can do priorities on thread. You can resume a thread. You can sleep a thread. You'll be able to get around it. You won't find that many samples for this operation. Now, as you see, the samples that Microsoft provides are really to connect to Azure mostly. You'll find on the net some samples if you're running sensors and machines and stuff like this. You'll find they are not that let's say easy to find if you are looking for Azure RTOS. You'll find it more for the old name. I'll say for NASA was good enough. For your machine, if you need to run a machine or to do something strange for which you need an real-time operating system, again, good enough. And you have all the components. This is a real operating system to run on top of it. Also, okay, the elephant in the room, it's if I can run Azure RTOS on Azure Sphere. So yeah, you can run on this. What's Azure Sphere? Okay, let me show you. I'm doing the unboxing yet again. What's Azure Sphere? Azure Sphere is three things. It's an chip design. It's an operating system and a service to keep update and secure that operating system. So that operating system, it's not for you to use. It's not a real-time operating system as something. It's an operating system that keeps secure your system. And this is a development board. I had an idea to run, I have a couple of Azure Sphere devices. The chip, it's the part. But unfortunately, on these boards, you have no sensors per se. And on the other boards, some of the free chips are used by the, I don't know why, but they are blocked by the Azure Sphere operating system. Anyhow, on a short story, they are using one Cortex nucleus for the Azure Sphere operating system. But the rest are free to use. So if you have a spare Cortex, you can run Azure RTOS. So you can run it even on this. So you'll have the best of both worlds. You'll have the system will be secured by the Azure Sphere, which is doing only security, and you still have an operating system running on the core, and they won't interfere. Especially they do not meet that much. So you can run it even on this. You find documentation. Unfortunately, as demo, it's pretty arid, like watching the paint dry. I need to explain to what I'm doing and what are the pins and okay, I've tried. It wasn't something that I did consider that would be interesting, especially, and this is an introductory session. I'm just telling you that Azure RTOS, it's an operating system. You can skip Azure and you still have an operating system. Yes, I'm telling you about IoT Central look around. I'm telling you about concept look around and stuff like this. Again, I'm really believing that this on in person will be a far better session than can YouTube one. But this is, let's say, my hope. Okay, we are still good in time. So we talked before about the GUIX. And this is the teaser that you recognize MX chip. And you see what they did on that display. The samples are not yet out. But okay, for this you need to write some code, but where you, let's say, modify the code. Let's say, you need to install from the store. Let's start it. GUIX Studio. So this is a store app. Okay. Azure. Let's. This is not a very smart. Okay, I won't put it on Telerik, even though it's a Bulgarian company, and I won't put it on. And here also you need to be careful on the length of the path. You see, this is it looks a bit more like a Java application. So you can add a string and say hello, and save, and okay, and you play with it. You have some leverage of creating visually a user interface someplace. Yeah, you need also a driver that will know how to do it. You'll see the teaser that will be. You'll get one for MX chip, and I'm really hoping that when this pandemic is over, we'll have the opportunity to do workshop even on this with the MX chip. Because anyhow, this is pretty easy to install. You come with your laptop. This is not heavy. If you have the devices, you can do, let's say, a lot. You have a bit of documentation in GUIX. It's not that much. And okay, let's click also this. And also you have all the samples. They explain you a lot of the stuff. What I need to emphasize, please do not do zip cloning and take care of the paths, because they did not. Zip cloning won't work, don't ask me why. For me, it did not work. I'm usually not cloning that many repository with git clone. I don't know why. Maybe I'm too old. So pretty much, okay, this they give you all the instruction how to do it. You can do pixel maps and so on and so forth. It's not what you expected if you are working with, let's say, with Visual Studio or Visual Studio Code. It's an editor in itself. But okay, it's far better than nothing. I've tried on my colleagues who are doing hardware, and I'll say they are far better on it than I am doing hardware, and they understood pretty fast how the stuff is working. Unfortunately, what they hate about all this, they love Azure RTOS as an idea. They hate the price of the hardware because they are, as some of our customers, which some of our customers are on the biggest companies in Europe or in the world, are multinationals. They are really driving us to a very low-cost hardware. So we had arguments of a number of resistors on an electronic board. They ask for the schematics. They say you have too many resistors. It's too expensive for us. Okay, so yeah, this is the trade-off. So let's see if this did not load. And if I'm looking, I'm right on time. Let's show you this yet again, and let us look also that here it's the temperature is still 30 degrees. This I believe is not well calibrated. It's something like 27 on the server. So let's try to do a short recap. Where we today talk about first Azure per se as an operating system. Azure, if you're treating whole Azure as like an operating system, you should bear in mind it's not computer real time. It's very fast, but in very few instances computer real time. Microsoft think about it, and they created for clients, hardware clients, embedded clients, created both an real-time operating system that runs on a lot of hardware. Okay, it's not the cheapest one, but a lot of hardware. Yeah, it has Azure in name, but this does not mean connection. You have a standalone operating system. Don't ask me about prices. They have stuff about prices. It's not something that Microsoft think yesterday. They bought a company, the company that was in the market for a long time. Let's say 1996. It's as long as I'm an engineer with a diploma. Good highlight pattern. Sorry, and so it's a lot of time. They are in the market. The NASA use them, so they know the stuff. Yeah, it doesn't have anything with Azure besides the name. You can run it on a lot of hardware. There is something called Azure IoT Central, and this is something you should look. And the IoT, Azure IoT, the part in the cloud, has some interesting concepts that you should be interesting to look around. And at the end, bear in mind that Azure RTOS has a lot of components that you can use, and you see it from TradeX, GUIX, and stuff like this. Let's see if there are any questions someplace. So if you have questions now it's the moment. We have let's say let's stop sharing and see me. I hope that somehow we'll be able to share the slides. The slides are just the important part. It's the links that I use in the presentation, and my contact. If you have questions, I'm always available to you. This is community work. I'm always ready, and so if you do not have a question, we're on the top of the hour. Most probably I will remain during the break, because with Andre we plan to do a non-politically correct discussion of everything and anything until he set up. if they do not kick me out. So thank you very much. It was a great session. I hope it was for you also, and I hope they're gonna see you in person pretty soon. So thank you very much. Enjoy your conference.
Okay, Katalin,
The
can you
rest of
hear
the
me?
conference.
Can you hear me from here? No.
So
Hello?
Andre,
Can you hear
you're
me?
on.
How are you, Katalin? How are things?
So I will do the comic relief. I'll say I'm being defensive. Some people told me that was the first time I did this presentation. Yeah, I'm usually trying to do on my community back home to do grading to see how the people respond, and yeah. Um, Unfortunately, the first delivery was online, so I'm not sure what is the reaction. So yeah, I'm hoping it was okay, because it's okay, new content. Oh, I'm always learning something new, and so. And yes, I do not hear Andre.
You are in. You need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there's a partner that could set it all up for you, operate it until it's up to speed, And then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. I think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heated smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawns. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch with many connectivity solutions for a smarter future. From Bosch.
Datavard is a global software engineering firm that takes a uniquely human approach to solving problems. With over 20 years of experience, teams of highly trained engineers around the world, deep industry sector knowledge, and ongoing technology research, we help clients create custom software that improves their operations and opens new markets. We integrate our engineering excellence with deeply human values that drive our business and our approach to relationships. Curiosity, empathy, trust, honesty, and intuition.
Hold up.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
So, you hear me?
Okay.
Yeah.
Welcome, everyone. Katalin, can you hear me?
Yes, I can hear you.
Oh, perfect. Okay, so we can try to do the talk that we tried just after your session. And first of all, welcome everyone. We'll actually start in 1 or 2 minutes. But before we do, it's great to have Katalin here.
I'm
Let me
glad
just.
to have you. Thank you.
Okay. By the way, this talk is going to be very strange because Katalin is on the other side of Europe, and I am in Portugal. He is in the other side of Europe, so it's actually
called
going to be.
Romania. It's
It's
near
actually.
Bulgaria. We have a border. We share a border.
Yeah, but it's still, everyone is in a different place, so this will be fun. Anyway, Katalin, you were just presenting a session on IoT. This was quite fun to watch. But a few questions for you. So IoT, with Azure IoT specifically, we can actually do things like adding cognitive services and making bots seem intelligent, and in the end, they will actually imprison us in our own houses. Will this be correct?
Yes. Let's say we talked this before, and you want to go to cognitive services. Yes, it's interesting, but now it's another new stuff going around. It's Azure Percept, which is a hardware that knows AI and it's connected all with Azure. It's something to look about. I'm hoping to get my hand on it. It's a problem in this part of Europe of buying Azure Percept. And now they're having two modules, one for vision, one for sound. and it's the one for vision, as far as I know. Okay, I'm not sure that I can tell this. What they have inside. But anyhow, let's put it this way: it's something built in this town specifically.
Amazing. We need to actually do more IoT. I think IoT is going to be the future, and you usually present a lot of sessions. Also, Michael, which is the main organizer for this event, usually also presents a lot about IoT. You
IoT
also
Summit
mentioned
Bulgaria. Well, we need to get there, but in
exactly.
person. We need to sample the beer with Michael.
It's all about the food, exactly. Anyway, another question. You mentioned IoT Central, and IoT Central is a very easy software as a service way to do IoT in Azure. It still uses the same components in the background, although you don't see it. But that just means that anyone can use it. Is that correct?
Yeah. So you've been the good trainer. You tell that it's as a service. Because IoT Suite was as a platform. Yes, it's as a service. It's the new stuff. It's pretty easy. It does the stuff that most companies need. Unfortunately, what our customers need is not like most companies. But yeah,
Isn't
the
always the
usual.
case. Anyway, you also have an alternative, which is the IoT Solution Accelerators. So if you search
Uh,
online, they have some examples. Not
they are
perfect.
deprecated. They are
Uh, yeah. Well, they are good to get you started, to give you an idea what you can do, but then you have to do the work yourself at all times,
Now,
right? So
now we are very hard to find. I would say Microsoft full effort is IoT Central. This is the feedback that they have. Okay, their customers, they have a point someplace. Not that I like, but they have their point.
okay, and I am getting to the part that will actually continue on to this session. And by the way, let me just mention that in just 1 or 2 minutes we'll actually start this. And just to say that one of the things that can also be used with IoT is Cosmos DB. So we're up to Cosmos DB at this moment, right? So any thoughts about Cosmos DB using IoT? Is this something?
They are going together very well. The only problem is that I hope that I have the money for all this.
I didn't want to mention price, but you are right. That's usually the
That's the
biggest.
only problem I see. But they're going together very well. I do not remember any English comparison going together like this. I have a blank, but they are very well switched together.
Anyway,
The only problem is the price.
Cosmos DB has a big advantage, and we'll talk about that during the session. And Katalin, feel free to stick around if you have the time
I'll
to
stick
actually
around, but
comment as well.
offline and anyhow, off camera, off. You do not want to hear the pussies around.
Anyway, I do have a cat here, so yeah, my cat should be around, but she will join in a bit. She's probably still sleeping. It's very early here in Portugal. But just to mention about Cosmos DB using with IoT. When you get IoT devices, let's say you have 1,000 IoT devices, you have 1,000 samples per hour, or even more. I don't know. If you multiply all of this, this will give you a very big number, which in most cases is impossible for you to store in a normal relational database. It's just too slow. So one of the alternatives is to actually use Cosmos DB. You can replicate it all over the world, so around the universe. Maybe in the future we'll have one in Mars and in the moon and things like that. You never know. It is possible. But
if you have Azure RTOS running around Mars, why not?
Actually, there was one thing we haven't talked about, and as far as I can tell, I didn't see this in the program now, but maybe we'll talk about this in the future. I'm planning to do some sessions about it, which is Azure Quantum. In this case, you can actually do quantum computing, which is slightly different, but it is extremely fast to do quantum computing. This is not so much for storage, but it's more for processing. But the future will reserve some interesting things for us.
Quantum, it's interesting. We'll see which one gets there first. It will be Microsoft, Intel, Google. I'll say there were some news in the, let's say, in the press. So
That is
we'll
correct.
see. Correct.
We'll see. This should be fun. Anyway, for everyone joining us, we are now starting.
So I have
Okay,
a nice session. I'll be around listening.
Okay, so thank you very much for this small chat, Katalin. We'll actually get started right now. So welcome everyone to the session. Thank you, Katalin, and thank you everyone who is joining us today. A special thanks for Michael that actually organized this conference, but also everyone like Stefka, Nicoletta, and Dejan, who's also helping out with all of these tracks and things like that. So we'll actually get started, and this was my cat. Hopefully, my cat will actually join us at some point in time. And if you've seen me around Bulgaria, this is normal. I did over 25 sessions in Bulgaria in the last 3 or 4 years. This is a place that I like to go. Bulgaria is so nice, and hopefully this will not be the last time I present for Bulgaria. But hopefully the next time, as Katalin said, will actually be in person. We'll see what happens in the near future. So anyway, we will try to do a session on Cosmos DB, which is to say that Cosmos DB, as I was just mentioning, is a globally replicated NoSQL database. What does that all mean? This is weird. So between the SQL and the NoSQL, that just means that a NoSQL will actually allow you to store information in a completely different, let's say, unorganized way. In a SQL environment, you have a table. You have a table with certain columns. This will always be the normal scenario, and we will try to use normal SQL things for transactions, for storing sales and things like that. But when we have the NoSQL is usually used for things like storing big amounts of data, let's say IoT samples if they come in a greater quantity, or if you just need to read them very intensively. Let's say you have an e-commerce website. The best idea to do it is to divide into multiple types of databases. Let's say you have the searching, you have the product listing, etc. Those can be in a NoSQL database like Cosmos DB. But then when you have the transactions, the actual paid money, the personal information, like your information about your address, about all of the things like that, those will actually show up in the SQL database, because that's the most efficient way to then process them, etc. And then when you have images and other things, you shouldn't embed them inside of a database. You shouldn't embed them inside of a SQL, or in this case, a NoSQL database. You should actually use things like an Azure storage account, so that you can, or a CDN, for instance, if you go global, so that these things are as optimized as possible, and obviously optimized in terms of speed, but also optimized in terms of the money that you spend. Okay, so let's have a look at a few things. This is going to be my session for Global Azure Bulgaria. It's not the first Global Azure I've done in Bulgaria, so I'm really happy to say that 2 years ago, is it 2 years already? This is crazy. 2 years ago, I was actually there. This was also very fun. They also had food. Now we don't have food. This is terrible. Anyway, but I do have food at home. I have pizza as a service, so that will work. Anyway, if you have any questions, this technology thing that allows you to share this into Facebook, into YouTube, etc., will allow you to ask messages. They will show up in the chats, and either I will read it, or Dan, feel free to interrupt if I forget to read any messages. But ask questions at any time, and I'm here to answer them. Anything except the meaning of life, well, I can actually answer that. It's the number 42. Everyone knows that. What does that actually mean? No idea. Okay, but that's a different problem. Anyway, let's have a look. Oh, I forgot the most important parts. My name is André Melancia, and I am this guy. So I am this guy, and this guy is the guy who's saying things like, the cloud is a quiet place where Cosmos databases are born, applications are developed, and NoSQL particles reproduce. This is the odyssey into the universe of Azure. So let's try to do this as a documentary. This is actually something that I did maybe 6 months ago when I delivered the session for the first time. I actually did a promo, and I decided to go crazy on this. But I always do crazy session, so why should this be any different? Anyway, let's get to the interesting things. And before I do, let me just say that this last 6 months was very big on monoliths, and even McDonald's came up with their own monolith, so this is very advanced. And also, if you live near the beach, there's also a different kind of monoliths. So I just want to make sure everyone knows about this, because you can actually use the last two for useful purposes. Okay, but now let's get serious. Anyway. First of all, as I mentioned, it's a NoSQL database. That means that the fields or columns, if you prefer, are not well defined. That means that you'll probably have something like an ID field. Those you will need to have to uniquely identify each record or each row, if you prefer, or documents as well. But in vertical terms, in terms of columns or in terms of fields, you don't need to have defined fields. So a record can have A, B, and C, D fields, but the next one can have A, D, and E, but not have the B and C fields. That can actually happen. Okay. Anyway, this Cosmos DB is actually very fast. It's also very fast to take money out of your wallet, so that can be a problem. Although in the cheapest possible tier, which is 400 request units, it will actually be free to have one of this in your subscription with the minimum value, which is 400 request units. If you have 401 request units, that means you will pay something like 23, 24, 25 euros, something like that. I'm not sure what the exact number is, but it's something around that value. But still, this will be very fast. You can also have this shared just on one single Azure region or shared in completely different regions around the world. They will replicate automatically. You need to do absolutely nothing to make this happen except to put a checkbox into the regions you want to share. And the more regions you have, the more you pay. That seems obvious. It's kind of linear in terms of payment, so that's easy enough. Anyway, as I mentioned, globally replicated, but there is one thing that I should mention which is important, which is in many databases you have your master and you have your secondary, and then you write to the master and the secondary just receives the changes, and you can only do reads. Here in Cosmos DB, you can do reads and writes into all of them. So by default, there is going to be one write region and everything else is going to be a read region, but you can say that everything can be a write region as well. And in that case, you can write to all of the places. Let's say people are here in Europe. Let's say I'm using West Europe, and in West Europe, I write to West Europe here, and that will replicate immediately to all over the world. If I'm in Australia and if I'm using multi-master or basically all of them have write options. That means that if in Australia I want to read things and I want to write things, I can do it directly there, and that will that will update back into Europe as well. Okay. Yes, there's the possibility of conflict. That can be a problem. But then again, you have to devise your applications in such a way that this problem can actually be solved. There is one or two situations to handle conflicts, which are built into Azure. The most typical one is to accept the last write. So that means that the last person who wrote to Azure will actually be the one that counts. Sorry about this, very early in the morning. As Kathleen said, we haven't yet eaten or drank anything yet. Anyway, there's also something which is multiple APIs. What is this? This might seem strange because suddenly you are seeing things like SQL, you are seeing things like Mongo, Cassandra, Gremlin API, and suddenly this becomes strange. So what is this? Is this a hybrid product? Is this an alien that mixes everything together and suddenly you reproduce like a Borg cube that mixes humans and all of the other life forms together? This is very strange, but it's actually simple to use. So what happens here is that Cosmos is a thing that has the infrastructure inside, but then inside of that, it will actually have one of these 5 APIs, maybe more in the future. Currently, these APIs. And how does this work? Well, a few years ago, there was something called DocumentDB. And DocumentDB was actually merged into Cosmos DB, called the first one called Core SQL, as you see here. Okay, so that actually means that this Core SQL is the same as DocumentDB. If you go to the documentation, if you see how you have to do codes to actually read and write from that, so the APIs, those will actually say DocumentDB for all things. You instead of actually using records or rows, you are actually moving around documents. These will be your individual records. They will be called documents, but still nowadays everyone calls them records or items, if you prefer, to actually uniform with all of the other ones. They just call them items. But the idea here is that you have a globally replicated DocumentDB, which is the old name, all over the world, so that works really well. However, let's say you have a MongoDB on premises or somewhere else, and you want to migrate that into Cosmos DB. So all you have to do is to use a tool which I'm going to show you in a bit to migrate all of the things into Cosmos DB. However, all you have to do is to say, I want a MongoDB Cosmos DB account, and then from there migrate everything, and you have a connection string. Go to your application that uses Mongo and just change the connection string. No other changes required. That is it. That is as simple as that. All you have to do is to change the connection string. Okay. So anyway, you can have Mongo, and Mongo will immediately be globally replicated. That means that all of the functionality that you have in Mongo, Cassandra, Gremlin API, even something called Azure Storage Tables, which used to be a very small thing for NoSQL, which was very cheap, of course. But if you start to scale this and your application requires a bit more capacity, you need to move into a bigger thing. And also, if you need better indexing of all of the fields, you need to move your storage tables into Cosmos DB. And for all of the 4 ones that you have at the end, and even the old DocumentDB things that you had there before, all of these will be supported in terms of APIs, the original APIs for each of these. So you have Mongo connectivity, you have Cassandra connectivity, Gremlin, you still have all of the language being fully compatible, etc. All of these will connect to any application you previously had, and things will just work. This is the magic, okay? All you have to do is to change the connection string to point to Cosmos DB, and you are ready to go. It's one small change that you would have to do anyway if you were moving the infrastructure somewhere else. But this is a very big advantage. There's obviously more optimizations. There are some that I might mention here, but there are other optimizations that you can check out later. But in a 1-hour session, this is not possible to talk about everything. So let's see what we can do in a 1-hour session. And by the way, these very nice images are images of something that they call stellar incubators, and these are basically where the stars are born. This is quite amazing to see that millions and much more billions, like with 12 zeros. No, maybe not 12, but anyway, many years ago, with a lot of zeros, these stars began to form, and the ones that we are seeing now are only now showing up. But hopefully Cosmos DB will be much faster in terms of microseconds, not really millions of years, to actually see the light and see the data reach us. So hopefully this will be the other way around. Anyway, we will try to do a demo on this. So first of all, this is my Azure portal, but how do I get here? This is strange. So first of all, if you never used Azure, and you are in a global Azure bootcamp for some reason. So it's to actually learn how to use Azure. But the worst part that I always see when we go to these bootcamps into all of these things is, yeah. We're seeing things in Azure that looks really nice, but I don't have an Azure account. I cannot use this. This costs money. This is terrible. So how do you do it? Well, you go to azure.com, you say get started for free, and then you press that green button to get started for free again. So you have to confirm you really want the free stuff, and then you enter your personal information, you create an account for free, and for the next 30 days you get a certain number of credits. This is 170 euros, or the equivalent in other currencies. That depends on what currency you are using. But in any case, you can use those credits for 30 days. Don't put the Cosmos DB to the maximum. That will spend that in maybe like an hour or two. So don't use that. But still, if you use Cosmos DB to the minimum, don't worry that this will actually be free. Okay, there's a free tier for that. But anyway, for 12 months, you actually have some services that you get for free once you create the account. And some of these are things like SQL databases, etc. Cosmos DB, as long as you just use 400 request units and you don't use global replications, so you just have a local region to test out, that will actually be free forever. So forever until they change it. But so far, this has been around for quite a while. You can also do other things that can integrate with Cosmos DB, like Azure Functions. I will actually not go into a lot of this right now, but let's say you put up a record or a row in Cosmos DB, and as soon as you put up something there, as soon as you write into it, you can actually call something called an Azure function, and that will trigger an Azure function, and that will run something. Let's say you put there some information that you need to process from some IoT device from Catalin just before. And as soon as you receive that, you will need to process that gradually. So you call Azure Functions, and you have 1 million requests per month. That's about 30,000 per day, and that would be more than 1,000 per hour. So I'm not sure what the exact number is. I'm just doing math very quickly, but 1,000 per hour is obviously quite a lot. So that means that as long as you receive 1,000 IoT samples, you can process them even for free, which is amazing. Anything else you'll have to pay, but it's like 0.00000001 euro or something like that. It's whatever the value is, it's actually very cheap for each run of function, but you can run these functions to actually process the data. Okay, so let's see that in the data you actually have some built-in things like an image or something like that. You can call on a function. The function extracts the image, sends the image over to cognitive services, and then you can do face recognition, and then you get the things like, who is this person? Let's compare to the people we have on file and things like that. So you can actually do that with Azure Functions. There are other ways to do this, of course. This is just an example using Cosmos DB specifically, but there is 1,000 different examples. By the way, let me just recommend that you go to something called Azure Azure Architecture Center, in fact, Azure Architecture Center. So you can go to docs.microsoft.com /Azure/ something like architecture or something like that. Just search for it there. It's actually very easy to find. And you have the Architecture Center. This will be the basis for examples that you have online. Anyway, if you have any questions during this time, feel free to ask. This is always very nice. Okay. And once you create your account, your free account, you can go here and go to your dashboard. You go to portal.azure.com. You will see your home view or your dashboard view. So there's a home and there's a dashboard. I like dashboards better because I can put up cats. It's always a bit more fun, of course. But in any case, we will try this out. Anyway, I've actually created my Cosmos DB account already because this will take something like 10 minutes to do, but it is very important for me to explain how to create it. So let's go here and let's search for Cosmos DB. It's actually down here already. Otherwise, you could just write Cosmos on top. So let's go to Cosmos DB. Okay, and with Cosmos DB, you actually have to write a resource group. So let's say a new resource group. So let's say ZZZ minutes, new Cosmos, something like that. Let's say okay. I'm actually not going to create it in the end because I've created this already. So so let's say Cosmic Database something. So this will actually exist. You have 5 APIs here. So remember, the core SQL is the one that used to be the old document DB. It's actually the default one. It's a very simple one where everything is JSON content. All of the documents to use the correct name, or basically the items or the records, are all written in JSON format. You can actually have hierarchies inside of that JSON format. This is okay. Even attachments if you'd like, but this actually uses JSON format. And then the stored procedures, the triggers, the functions all use JavaScript to actually write things. We will see this one specifically. If you are a fan of Mongo, or if you have used Mongo or Cassandra or even Gremlin API, you can actually start with one of these three. If you use the Azure tables, which is the very simple Azure storage tables, you can actually migrate to this. By the way, all of these things can be migrated using the migration tool for Cosmos DB that I'll show you in a second. This is actually called DTUI. We'll see that. There's actually a command line interface as well, but we'll use the graphical tool. It's much easier. This is obviously a Microsoft product, so why should you use a command line tool to do something that graphically can be done in a very easy way? But it is important to mention that all of these things can actually be done by scripting. So to create a Cosmos DB account, to change it, to do whatever you want, all of that has APIs and SDKs to do everything using codes. If you are a big fan of DevOps, you want to automate everything like migration of data, anything like that, everything can be done using code, but we'll do this graphically because it's much more fun, of course, right? But the rest is easy, so just figure out how to work with a graphical interface and then just do that in code later on. Anyway, first of all, let me just choose location. One mention to say that in the last 2 weeks, West Europe, which is actually my favorite to use, West Europe is actually a bit flooded. So if you choose West Europe, this would be the best one that I usually use. But in the last 2 weeks, it's actually a bit slow. Okay. So sometimes you deploy things there and it fails, like big things like Cosmos DB and Synapse Analytics. But try North Europe now, or any of the other regions close to you. Those will probably work. If you are in a different continent, try something else, which is still okay. Anyway, you have two options here. Next up, we have provision throughput. That means that you pay 400 request units, or this is the minimum, or something else, something bigger. And with that, you always guarantee that capacity. If it is serverless, that means that you don't pay for any capacity in real time. You only pay when you start using it, and that will have a timeout, and then it will turn itself off, etc. The problem is to actually get started. It will take a few seconds or even minutes to actually start up if it has been stopped for a while. So that can be slow. That's great for ETL processes. Serverless would be great for any kind of ETL process that you run once a day, but it will not be good for things like real-time, I don't know, e-commerce website or something like that. For that, you need provisions. Now, I'm going to use provisions, and this is free up to 400 request units, okay? By the way, it says apply free tier discount. This is the one. Why can't I use it? Because I already have one that uses the free tier discount, and you get only one. Okay, so you were supposed to click the apply here. This is the one that I already have in the other account, and then you can actually say production or non-production. This will actually help as well, but because we are doing testing, let's assume that this is non-production. So remember that this looks slightly different and works slightly different, but so far there is no major change that I need to mention. Anyway, global distribution. So geo redundancy, if you say enable, that means that you have at least one copy in a different region. So those will be in one or more different regions. If you have multi-region writes, that means that instead of having only one region to do the writes, you actually have a whole bunch of regions to reading and writing at the same time, which is nice. In terms of availability zones, that means that inside your region, let's say you have one region, you actually have more than one data center in some cases, and that means that you can have redundancy inside the multiple data centers in there, which actually works really well. Okay, networking is easy. So all networks, that means that you have a public IP address and you use it publicly. This is the one we're going to use for simplicity, but you can actually increase security by putting a public endpoint and putting this inside of one or more virtual networks. So you can specify one or more virtual networks, or you can do something which is even better. And this actually works for Cosmos DB. This works with SQL databases and much more, which is to create something called a private endpoint. And that means that you have your Cosmos DB database or your SQL database, you have a website somewhere else, and instead of going through networking rules to get from one to the other and actually open up things along the way, which can be a security risk if you are using other services as well. In this case, you literally connect a wire from A to B. And that means that there is nothing else going on in the middle. You don't need to define any more rules. It goes directly from your database into your web service, and this guarantees the best possible security without having to worry about opening up rules along the way, which can reduce your security. But in any case, for us, in terms of demo, all networks will be the best one. Okay. Also, backup policy. I usually show this in the other side, but nowadays we have a wizard here. So basically you can have a backup retention policy, which is 8 hours. You can have a backup interval in which, in this case, this is 4 hours in terms of time. So every 4 hours you can do a backup. You can actually do this every 60 minutes if you prefer, but then you can have backups that get stored up to 30 days, something like that, which is okay for all of those. And then they actually specify, based on the numbers that you write, how many copies you get. So every 4 hours, retain 8 hours. So that means you get 2 copies at the very least. This is actually the minimum. And then you can actually say how you want to store the backups. Locally redundant backup storage is the cheapest. This doesn't cost that much, but Cosmos can be very big, and then payment will be expensive, but this is just storage prices, so this is not that bad. Storage prices are cheap. These are not CPU compute prices. Anyway, locally redundant, that just means that you have just one copy locally on one data center inside of one region. Zone redundant, that means that inside the same region you have a copy in multiple data centers. So West Europe can have data center 1, 2, 3, at least 2 anyway. And then geo redundant, that means, let's say if you are in West Europe, you get a copy, let's say North Europe, with those backups. So that means that if there was a meteor, and a meteor in space, in Cosmos, this is very normal. If a meteor actually hits the data center, you need geo redundant backup so that the other location will actually keep a copy of it. You'll probably be dead if the meteor hits Europe, but in any case, you get the idea, right? At least the data will survive, so that millions of years later, there's going to be some alien that comes here and actually reads the data and see, oh, these people were crazy on Earth millions of years ago. Anyway, encryption, you can also encrypt things. By default, this is already encrypted, but you can use your own keys if you prefer. This is actually a requirement if you are using, if you have some compliance rules, some policy compliance rules for banking industry, financial, etc. And then you can just say review and create. I'm not sure if the validation, yeah, it's okay, but you can just say create. Now, obviously, this will take about 5 to 10 minutes. It says 14 here, but you get the idea. But I will go directly into the Cosmos DB account and actually demo it. So let's go to the Cosmos DB account here, and let's try it out. So I'm going to get rid of this one and actually try this out. This will be fun, and this will just take 1 or 2 seconds to actually load. So anyway, features. One of the things you can enable is Synapse Link. So if we have time, I'll show you this in Synapse Analytics as well. This will be fun to integrate Cosmos DB with Synapse Analytics. But you need to turn this on first. This is important, okay? Otherwise it won't work. Replicate data globally. It's also very easy to do. So you go here and say, look, I want to have this one, and this one, and this one, and just click some copies of this. By the way, they will complain about some prices, etc. But you get the idea. So you can add one or more regions. You can define if you want availability zones in one or more of this. North Europe does not have an availability zone because it only has one data center, as far as I can tell. But maybe in the future it will. West Europe actually has 2 data centers. By the way, I'm saying this today, but this will change over time. So if you see this video in 6 months' time, this can be completely wrong in terms of what the zones are anyway. By the way, not all regions in the map are available. Why? Because although there are maybe twice as many regions in the map nowadays, not all of them support Cosmos DB. And because of COVID and things like that, they're actually focusing some products only in some regions. So that this will not flood in terms of computation and things like that. So they are trying to manage things. For instance, this yellow one says, or white one actually, says it's using high demands in that region, so they cancel. They don't allow you to deploy there. If it's already there, that's fine. If not, they don't allow you to have it there. Anyway, multiple region writes, that means that everyone reads, everyone writes. Currently, there is no control to just have certain regions for reading, certain for writing. Everything is read, everything is write, or there's only one read. So far, this is actually the scenario, which is still okay, But we will see a few more examples. I would have to click save, by the way, to actually make this work. By the way, you can move data from one region to the other gradually and change this, but just remember you need to keep at least one at all times. And remember that if you are changing some of these regions, they will actually take some time to actually move data. Okay, so over time you can actually play around with this, migrate from one region to the other. I actually lost this. This is crazy. Okay, but in any case, you will need to wait until all of the data is synchronized. That's if you are sending things to a new region, that can take a few hours, sometimes minutes, but maybe a few hours, depending on the size of the data you are sending. Anyway, there's something called a consistency, and the consistency. This actually depends, the default of this actually depends on the kind of API that you are using. So Core, SQL, or Mongo, or Cassandra, etc. This actually depends, but in this case, let me just try to explain what these are. So if you are on the strong consistency, that means that I am an application, I write to Cosmos DB. Cosmos DB will wait for everyone around the world to update the information. And when this is done, it will actually return to the application and say, hey, okay, this is all updated. This is what you get in a SQL server or something like that. Until everything's okay, it won't return to the application saying, everything okay. This is the strong, so you get as best as possible here. It's also a bit slower, of course. You can have the eventual, in which you just send it out to Cosmos DB saying, please update this, and then it's fire and forget. Who cares if this is done or not? Okay, so it's just a quick update. This is normal. Eventual is normal when you do things like IoT. You just fire and forget, and you write all of the samples coming in from IoT devices, right? However, this has a problem. Let's say you do a query afterwards to get the data in the same region, but the same region might have your writes still queued, and then you still see the old data, which can be bad. Okay, so to actually fix that problem, you have something in the middle, which is session. That means that session guarantees that in your region, the one you are connecting to write things, you'll actually send this out there. They will write to that region first to guarantee that it's actually written, and that will return to the application. Any queries that you do with that region then will always be correct based on the information that you wrote, okay? However, to spread to the other regions, that will take whatever amount of time it takes. It will eventually be updated in the other regions, okay? And then you have something in the middle, the other two in the middle, which add a bit more and a bit less respectively to these things, but the behavior will actually be slightly different depending on the APIs that you use, okay? This is the general idea, then the APIs are slightly different. But anyway, you get the idea how a local update or a global update will actually work, right? This will actually be different. Anyway, then you have things like backup and restore. We talked about this already. And you have things like firewalls. So we talked about this already, private endpoints, all of that. You also have keys. So please don't copy my keys right now. This would be a bit bad. Okay, and we'll actually use some of these keys to play around with this, but we'll see. You can integrate with Azure Functions as well. You can integrate that with things like advanced security. All of this will be easy for you to integrate or to integrate with. So this thing, Advanced Threat Protection, is actually part of the Azure Security Center and all of those things. So you can actually use them. One second. You can actually use them very easily and make sure that security is also guaranteed. But let's have a look at actually trying some of this out. Okay, so let's go to Data Explorer. Okay, so 1 second, please. Let's go to Data Explorer. And right now, I already have some 2 databases. Okay, so a to-do list was actually created in a demo. There was a demo if you do a quick start. Although this demo, which is create a container and then download the .NET application, for some reason I tried it this week and it had some bugs. So please wait a few days. Maybe this will be fixed, etc. Okay. You can also try this out with a notebook. That will be fun as well. But I'll actually do this manually. But you are free to try this out if you'd like. Okay. Anyway, let's give this an example. Okay. So an example of this would be to create a new container. And to actually do that, when you get started, you actually have nothing. So you can say create a new container, but that will actually suggest creating a new database as well. This is the time that I show you some slides, okay? And basically, this is hierarchy. So first of all, you have a database account. That database account is actually here on top. And then you actually have some one or more databases. This is the same as a SQL database where you have an instance of the server, and then you have multiple databases inside. And then afterwards, you have your containers or different names, collections, tables, graphs, etc., which are basically your tables in the end. So these are equivalent to your tables. There is no schema in the middle. If you come from the SQL world, there is no schema, but you get the idea. Anyway, you have databases are always the same name. Containers might actually have different names depending on the API that you are using. So it can be called a container, it can be called a collection, it can be simply called a table. So for instance, in Azure Tables API, this is simply called a table. If you are using Gremlin API, because Gremlin is not a NoSQL traditional thing, it's actually using graphs that join things like, let's say, cities in a map, and then you connect the cities in a map with roads and things like that, and you write them all in the graph with nodes and edges. In that case, this is actually called a graph, but the names will be slightly different. But then in terms of storage, they will actually store the whole thing. Remember that the database account can only be of one type, and that would be either, Cosmos DB Core SQL or Mongo or Cassandra or Gremlin or Azure Storage Table. So it has to be one of these specifically. So that can also be a problem. But in any case, we can tell that inside of this, then there can be a few other objects. So first of all, containers will contain items or records or rows, or if you are using DocumentDB, they're called documents, rows, and then you can have also nodes, edges as well. They can have different names depending on all of these APIs, but in the end, they will be slightly the same. Okay. Anyway, you can also have stored procedures, and these are the same as SQL. So you execute some code. You can have some user-defined functions, and this will be used for things like doing selects and then calling the name of a user-defined function with parentheses, and then inside using some field. We'll try one of these. Merge is merge, of course, procedures. What are these? These are basically normal procedures that are used when you have a conflict. You can use the last one that was written. This is automatic, or you can create your own merge procedure so that this updates the old record and the new record, and you get to decide how to join the two together. Okay, this can have different rules depending. Okay. Anyway, you can also handle the conflicts from here as well. So this is actually used as well. Triggers, this is the same as triggers in a SQL Server. Every time you write something, you can trigger something, and that will even mean trigger something internally or send this out to things like Azure Functions and things like that to trigger something out. You can actually send this out instead of Azure Functions. You can actually send this out to Azure to event grids, which allows you to trigger anything else, which is also okay. Anyway, let's go back to the demo. And now let's create a new database. So DB live, okay. So let's call it DB live. You have the auto scale or the manual. Be careful, the default is actually very big and it will cost a lot of money. But if you call on manual, and if you just say 400, this will actually say $23 per month. It's like 20 euros or something like that at this moment. But if this is the first one that you do, the first one is free. But then as long as you use 400, the first one is free, but I already have two databases, so I'm not going to get the free anymore, right? Anyway, container ID, so let's say table, and then I'll actually have table people. Okay. And then indexing, let's keep it automatic. Partition key. So one of the things that happens is that the hardware will actually have different nodes so that you can store the information. This is the same in multiple technologies. This is basically using sharding, but this is done internally. You don't have to worry. But they will need to know how to divide the information among things. So things like a zip code and things like that actually make sense. But if you don't have one, just use the ID value. By default, you have an ID. Just use the ID. Just be careful, it is lowercase because the ID is also lowercase. And then you just divide randomly based on the ID address, the ID fields. And if you don't have a partition, just use the ID field. And in that case, it will not be perfect, but it will try to divide things around, which will be okay in some cases. Anyway, analytical store, that will be on as well. So that means connecting to Synapse Analytics if you'd like to see the results. This will also be fun, okay? So this will take a few seconds. By the way, if this demos fail, and a lot of things fail, okay, so just recently there were some rockets that blew up for that other guy that's invaded that other country and things like that, or that liked people invading that other country. But anyway, let's try this thing. So first of all, scale. So what is scale? So it's the size. You can change the size here, which is okay. And then you actually have, and you can change the size here for database. You have a table for people. And unlike the SQL, normal SQL environments, your context is not your database. Your context is actually your table or your container. Okay, so that means that if you do a query, you're only seeing that table at this moment. So first of all, I have no data here, which is normal. Okay, so what I'm actually going to do is I'm going to find some data. Okay, and please forgive me if I just copy paste things. Okay, but I am lazy by nature. This is normal. Okay, wait a minute, cancel. Okay, so you have an ID already, so let me add an ID, and this is the name of something. Oh, I have an extra comma, that's why it doesn't save. It will only allow you to save if it is valid. Okay, so this one is a person named Paper. This one will be a person named Rock. So let's call this second person Mr. Rock. Okay, so let's click save. And then the third person will be a person named new item, a person named Scissors. So let's click save. And then we have a person named, new item. So you have a new item called Miss Lizards, and let's say save, and then new item, and then the last one will be our own Mr. Spock. It is illogical to think that I would not be here. Anyway, so right now you have the ID, which is 12345. This was simple. It can actually be a string, but I just put this as numerical. Your partition, in this case, I've actually used the same, so it's not interesting. But let's actually have a look and go here. By the way, the icons are not very explicit, but if for some reason, let me just shrink this for a bit, but if for some reason you click or you hover on top, it will actually show you what that actually means. And let's execute a query. So you actually get paper, rock, scissors, lizard, and Spock. Okay, so you have all 5. This is actually nice. However, from C, but this is not called C. Well, this is strange. But I just mentioned that the context of this was not the database; it was the table. So you don't need to name the table. But if you want to, you can actually say table people as C if you'd like. Okay, so yes, you can actually do that. This will actually work. Okay, so it's not really a problem. But the problem here is if you say, so we have a first, actually let's call it last name. Okay, if I write this, this will fail. Why? And the error is very strange. You just think, oh, I broke up something here, but this is just simple, like adding the alias before. That's the only thing you need to do. Okay, so C dot something, and you have paper, rock, scissors, lizard, and Spock. Okay, so that will actually work. Anyway, we can actually do a few other queries, but we can spend all time doing this. You can do wheres, etc. By the way, if you say where, let me just show you a quick where. So where C dots first name is equal to Mr. and let me add a dot. By the way, this is double quotes. Okay, this is important. By the way, if I execute the selection, I'll only execute the quote. So make sure you don't have anything selected while executing. Otherwise, you just execute small parts and you get a weird error you don't understand. But anyway, I can just get the Mr. and then see Spock, which is the only one that's actually on the list. So this is easy. Anyway, let me just add. So add a user-defined function. Okay, stored procedure is just a bit of code in Python, in JavaScript, so it's not interesting. But let me just copy paste this. So this function you probably seen or done functions like this a lot. It's just a function based on age. I need to put the name of the function here as well. Age group, if age is something less than 3, it's a baby, child, teenager, adult, or older than that. So let's click save. Okay, so this should be easy. The save, yeah, okay. Oh, yeah, is there an error? Okay, so there might be an error. No, this is okay. So is this a user-defined function? Oh, there was an error because, no, yeah, it's okay. So bug, okay, let's try it anyway. Let's try a query again, so should be okay. The thing is there anyway. If it fails, I'll actually copy from the example from before. One of them will actually work. Anyway, you get some of the values, age and then age group. So let's see if I can execute the query. And then you have age 138 for paper. So that's older, adults, adult, baby, and then adult as well. Okay, this is Spock's age when he died in the Wrath of Khan, the famous, one of the most famous films where they say Khan and things like that, where Kirk actually says that when the guy dies and things like actually a bit later, but that's okay. Anyway, so this is stored procedures, user-defined functions, triggers. You can add some of these, and you are always using this kind of codes in JavaScript, so anyone can understand it. It's not difficult. But yes, if you don't like JavaScript, I'm not a big fan, to be honest. I would prefer C#, especially because of things like data types and things like that. But yeah, nowadays in other scenarios, you actually have TypeScript that solves that problem and things just work. But here you can use simple JavaScript to do these kind of things. If you come from a SQL world, you are used to T-SQL. That's slightly different, but you use the same things. Anyway, one or two more settings very quickly, and then hopefully we'll have some time to show you this in Synapse Analytics. Anyway, time to live, that means that if you have a record like coming from an IoT device, if you specify a time to live is equal to 1 and specify, let's say, 3,600 seconds, after 1 hour, that means that those records will automatically be killed. Okay, this is automatic. If you say is equal to on, but don't specify the TTL, and there's a TTL field that you can have, if you specify this is equal to 1, you will need to add a field called TTL to actually say when it will expire. So to give it the definition in terms of time when it will expire, and then that will expire differently for each record. Okay, you also have things like indexing policy, in which by default it's automatic, but if you want to change it, you have to do this code and actually include things, etc. You actually have to add this manually for all of the includes, for all of the excludes, etc. But this is still okay to actually write down. Okay, I'm not going to change this, but just to give you an idea. Anyway, I also have something called Synapse Analytics. Now, Synapse Analytics, all you have to do is to go to the plus sign and actually call on Synapse. Okay, actually call on Synapse to actually join this. So Synapse Analytics here, okay? And you will actually have to create it, etc. This will be fairly fun, but this would take a bit of time to actually explain how to create it, but it's a wizard similar to the other one. But let's go to the Synapse location, go to Synapse Studio. So you can open this up in Synapse Studio. By the way, I'm still going to do, I'm going to show you this very quickly, and then I'm just going to show you a demo how to import data into Cosmos DB. Okay, that will be the last part of this, but just before, I'm going to show you this in Synapse. So what is Synapse? This is actually an infrastructure that allows you to use SQL Server technology, so SQL Server engines in data warehouse format, and also use Spark, so Apache Spark, to process all of the data, and all of the data mixes in together. So you can have data coming in from one second. So you can have data coming in from databases like a Spark database that has a table, or you can come in from serverless. You can create a serverless database, so you can create a SQL server here, a serverless database, which basically is a database that has no physical space stored on disk. It's just, it just links to other databases in external sources, but you can still query them using SQL, so that's fine. You can have a dedicated one, but then you have to go to manage here to actually create it, but be careful, always create it in the small possible tier, because if you try to create a SQL pool in the cheapest tier, I'm not going to do that, this is not the purpose of this session, but if you create some dedicated pool here, that will cost 10 euros per hour. So this is very expensive, okay? Cheapest one is €1 per hour, but in the end, you can actually pause it if you'd like, okay? So that's okay, and stop spending all of that money. But €1 per hour is a lot of money, okay? So please be careful. And it can go all the way up to, 300 euros per hour, and that would be 250,000 euros per month, something like that. So that would be completely crazy. But in any case, these pools can actually have 60 different nodes. These can be logical or physical, in fact. Different nodes where the information is stored and processed massively, 60 nodes at the same time. So this is completely amazing to work with. Okay, but I'm not going to create one of these. I'm just going to use the serverless one. For demos with Cosmos DB, this is more than enough. But if you haven't tried Synapse Analytics, you should try it. This is very fun. But anyway, I have some external tables here, some external resources, some views. I've created some views along the way. But linked, you actually have a plus sign. You can go connect to external data, Cosmos DB, okay? And then you continue, and then you have to add Cosmos DB accounts. That account, database name, you have to choose the database. So let's go to DB Live. So this is the one I've just created. Test it, okay? Should be okay. And then connection successful, create the connection. I actually have the connection already. Actually, I don't. So Cosmos DB live. So let's call it live. So let's say create, okay. And let's actually, it was already created, so it wasn't that bad. So if I refresh this, it was already here, but you get the idea. So let's say refresh. Actually, no. Yeah, this one is the parallel universe database. So it will just take a few seconds to refresh. In the meantime, you should go here and actually get some keys. So we need to go here and actually go and get some keys from here, okay? And you need to get this primary or secondary key. By the way, read write or just read only, okay? I'll actually create a credential string. So the example is already there, but I'll use this one. Okay, so Cosmos DB Live is here. So table people, and from here you can actually create a new notebook and create a Spark table that refers to that. So it's basically a link, and then you can go to this workspace and read from this Spark table from inside of Spark. The SQL engine inside of Spark, you can actually use the table from there as a linked table. This is amazing. But let's do this as a select top 100 rows in the SQL world, in our SQL Server kind of world. Okay. So built in, I've created a serverless database, and then you have, use this credential, etc. So I've already copy pasted this with that secret, which is your key. Okay. And then I can actually see DB live, table people, and then run. Okay. So if you ask to run, this will take 1 or 2 seconds. First time, this actually takes 1 or 2 seconds, but this will actually run. Anyway, we're almost running out of time, but I will still show you this and how to import things. This will take like 2 minutes. Think that this is okay. It's actually lunchtime, so I'm not filling in on any other speaker. I think this will be okay. By the way, I had the credential here already, but still for demo purposes, I should show you how to do it, so that's okay. But I had that credential there already, so now I have my paper, rock, scissors, lizard, Spock. So I have now all of that, which actually shows up here, so this is okay. And from your SQL world, you can actually do whatever you want, like let's say sum of ID. This will be an absurd sum, of course, but if you ask for this you can actually get the sum of 1, 2, 3, 4, 5. So you'll actually sum all of this together. Okay, so 1 second. So we'll take 2 more minutes. Oh, sorry. By the way, this sum actually isn't working here, but I think you get the idea. You can do this. By the way, you can create a view based on this. So like select star and then create a view. Create view based on this something here, okay? And then if you create a view, you can actually create it. And from the other side, wait a minute. What am I doing wrong? So select... okay, so select top 100 star from this. Okay, let's try this one. So what am as. Okay. So yeah, almost finishing. Give me a second. Okay. So Dehan, I hope it's okay, but we'll just take 1 or 2 minutes. I'm usually famous for spending a few time extra besides the normal one, but hopefully this is okay. Anyway, if you go to your SQL worlds, you actually have something here, the one that I just created, and select top 100. I might be lucky to actually get the results. Let's see, let's hope. Yay! So it is here. So it actually works, okay? So from your SQL projects, from SQL connectivity, you can actually see it. Okay, one very quick last demo, okay? So you actually have something called an Azure Cosmos DB data migration tool. This will be my last demo, okay? So source, you can actually get source from Mongo, from CSV files, JSON files, whatever you want, okay? You can say add files here, and then I'm actually going to add a file which is your solar system. So let me just open this with Notepad. Oh, it's actually opening Visual Studio, but let's say open. It will open on this side with Visual Studio, and I will actually try to upload things, okay? So you get the file. Let's click next. And then connection string, I actually have a copy paste here. So you use the same connection string as before, but you actually have to say database is equal to something. Okay, so give me a second. So you go here from database is going to be DB live. Okay, so this, as I mentioned, is my last demo. Very fun. And database is going to be this one. You verify. And then you need the collection, which is table people. Okay, so let's copy table people into there. So collection is going to be this one. And then you can just click next and import the data. By the way, because this one is people, it's a completely different one. That will simply sound strange, but I can import it just the same. Okay, but it will have different fields. Remember, it's a NoSQL world, so it will look strange here. But if I click this again, it will actually have a whole bunch of planets. So these were the planets that I've inputted, okay? All of the planets, but this will look strange because you now have paper, rock, scissors, lizard, Spock, and then you have some other planets as well. So actually, top star, give me a second. So star, and then you'll actually have all of the other planets here as well. Okay, so select. Oh yeah, this is this is actually the view, but still you get the idea that things are here. And if I do a select start from here, this will actually show up with the remaining fields, like the name field and things like that. The other one I was showing was a view, so it didn't work like that. But now I have nulls in this, but you actually have a view here. So this actually works. Anyway, this was my demos for all of this, so you can try this out. As you can tell, this is very easy. Just to finish off and give you some links. So docs.microsoft.com, all of the documentation is there, including one of the things that it's not going to be enough time to do in a 1 hour session, which is to show you how to do actual programming. But see some of the examples that they show you in the quick start tab. That will help. Microsoft.com/learn. Search for Cosmos DB. When you go to browse paths, you see all of the Cosmos DB things and you can get started there. If you go to github.com/Microsoft Learning, search for DP200s, or also there is something called the course 20777, which is Cosmos DB specifically. You can have a look at the labs for Cosmos DB. And finally, never go to pricing or you will be scared. Okay, that's important. Anyway, I haven't seen any questions, but if there are, please ask them now. We're almost at the end of the session. Okay, but in any case, while waiting for questions, if there are any, I want to thank everyone for helping out. So Dejan, really thank you very much for moderating this session. This was very helpful. We actually had Catalina in the beginning of the session to talk about some things related to IoT and a few more. I want to thank Michael, and I also want to thank Nicoletta and Sefka and everyone involved in the event for making this very big event possible. And next time, hopefully I will be there in person like I was in October, but we will see. Beers and things like that, this will be for the next time. Anyway, thank you all for being here. Have an amazing lunch and stick around for the next sessions. These will be quite fun, and have fun in Azure and get in touch as well. And we'll talk soon. Okay, thank you all very much, and especially Dan, thank you very much for being here and moderating the session. Talk to everyone soon. Thank you very much.
Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there's a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
start my days like a boss. Sun rays, I tap the phone, coffee's on, I mow the lawn, impressing Sean, so connected, so effective. I let it drop, clean it up, heat and smart. I do my part, get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch with many connectivity solutions for a smarter future. From Bosch.
Datavard is a global software engineering firm that takes a uniquely human approach to solving problems. With over 20 years of experience, teams of highly trained engineers around the world, deep industry sector knowledge, and ongoing technology research, we help clients create custom software that improves their operations and opens new markets. We integrate our engineering excellence with deeply human values that drive our business and our approach to relationships. Curiosity, empathy, trust, honesty, and intuition.
Hold up.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heated smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stocks. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch with many connectivity solutions for a smarter future. From Bosch.
Datavard is a global software engineering firm that takes a uniquely human approach to solving problems. With over 20 years of experience, teams of highly trained engineers around the world, deep industry sector knowledge, and ongoing technology research, we help clients create custom software that improves their operations and opens new markets. We integrate our engineering excellence with deeply human values that drive our business and our approach to relationships. Curiosity, empathy, trust, honesty, and intuition.
Hold up.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days. Sun rays, I tap the phone. Coffee's on, I mow the lawn. Impressing Sean, so connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch with many connectivity solutions for a smarter future. From Bosch.
Datavard is a global software engineering firm that takes a uniquely human approach to solving problems. With over 20 years of experience, teams of highly trained engineers around the world, deep industry sector knowledge, and ongoing technology research, we help clients create custom software that improves their operations and opens new markets. We integrate our engineering excellence with deeply human values that drive our business and our approach to relationships. Curiosity, empathy, trust, honesty, and intuition.
Hold up.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Okay, so I think I'm live now. Dan, if I'm not, just tell me something here in the chat. So I would just like to welcome everyone into our session here in the Global Azure. So my session is about governance, and the title is basically I find your lack of Azure governance disturbing. Basically, that's the idea. I always like to start my presentations with just a small icebreaker. So I hope you enjoyed. And this one is basically if coffee in the morning, okay, doesn't wake you up. So if this kind of stuff that just doesn't work for you anymore, well, try to delete the production, okay, a production resource group, okay? Because to be totally honest with you, if that doesn't work for you, I really don't know what will work for you anymore. Okay, so doing my short presentation. So my name is Tiago, and no, I don't look like the Global Azure logo. Okay, I have a face. It's here. Okay, you can also see me here. But basically, I work as a cloud architect and an advisor. I'm also a trainer, so I usually help my customers getting qualified to work with Azure and other people to get certified and all of that. I'm also the author for some of the Azure courses for Microsoft and for LinkedIn Learning and other platforms. And I'm a speaker in this kind of community events, my favorites, and I also speak in other larger events like, for example, Microsoft Ignite, etc. But I have to confess that this is my favorite event of the year, is the Global Azure. Being a person that works with Azure, helping organizing all of this, it is quite astonishing. And by the way, this is already my 5th event of the day, so I've already been in 5 different cities. So it is quite amazing, and I always like to jump around also as an attendee all day from sessions to sessions and see sessions from all around the world. We cannot be in person, but it has these advantages, okay, to be able to watch events from all around the world. And then, yeah, I have a bunch of certifications. I'm an Azure MVP, etc. But what matters more here is my contacts here on the bottom. So if you want to reach out, just please reach out. I also have my Twitter handler over there. So if you want to follow me on Twitter, please do. It's easy. It's Tiago Costa PT. I always share cool stuff around Azure and around certifications. What's going to be our agenda today? So I'm going to start to talk about basically what is the cloud today? Okay, how is the cloud complex today? Azure subscriptions, management groups, Azure policies, and then our back, and then cost management. So it's going to be a fun journey. Okay, so let's talk about the cloud. What is the cloud today? Okay, so the cloud today, we have it's complex. Okay, let's be honest. We have millions, okay, of cloud resources running on the cloud. We have customers that, okay, they have like, I have customers that we have hundreds of thousands of resources running on Azure. Managing all of that, it is wow. How can I say? It is quite complex. Okay, so it's definitely not easy. So we need to find a way, okay, to be able, okay, to manage all of that. But if we step back a little bit, isn't that what we have done in the on-prem world, where we had those very large enterprise customers? We had some kind of governance, we had some kind of organization in all of that, so that, yeah, we could make some use of all of that. Sure, so we already were doing this in the past, so it's not now, it's just, yeah, we can do it now in a slight different way. Okay, and then look, we live in a hybrid and multi-cloud world. So let's start with the hybrid part. I don't have the hybrid thing in here, it had space for that. But the hybrid, yeah, we have stuff on-prem, we have stuff on the cloud, and it's going to be like this for a while. So another layer of complexity. And if we even have to add another one, is that we live in a multi-cloud world. That multi-cloud world means that my customers, sometimes they have, like, for example, Amazon. Amazon, so basically AWS, they have GCP, Google Cloud Platform. And look, I'm not going to be the person that say, oh, don't use that. If you want, if you like it, if it works for you, great. Because look, AWS and GCP, they're awesome platforms too. And what matters is that our customers, they have what they want and they run what we want. But now, this just adds another layer of complexity, right? And the extra layer of complexity is what? Is that we need to find a way to be able to manage all this together. And that's not easy, let's be honest, okay? And then we also have this cloud complexity also, is that we have all this across business units, across projects. And again, look, it's definitely not easy to manage all of this, etc. So yes, this is something that you have to take care, okay? And if we see cloud management capabilities, so what do we have with cloud management capabilities? So basically, we have all this secure, protect, monitor, configure, and govern. So what is all of this? So yeah, in the secure part, I can do security management, threat protection in order to build better environments for my company. I have to protect those environments by using backups, by using disaster recovery scenarios. I have to back up my stuff. Like, I have things in one data center only. If something happens to that data center, I don't have my data anymore. So I need to have my data backed up somewhere else. Isn't that what you have done in the on-prem world? Like, oh, I have my data center here. I build a secondary data center so that I can back up stuff there. Or I was doing tapes, and then I was shipping the tapes off-site in order to, if something happens to my building, I have backups somewhere, right? So it's not because it's the cloud that is full of unicorns and rainbows, and that just doesn't happen, and you don't need to do backups anymore, because you need to do it. And everyone probably knows about what happened with a data center from OVH in, I think it was France, that just burned down. Okay, so it was really bad, right? So imagine that you had data there. Imagine that that's your only copy of your data because you didn't need any backups on that. Well, bad luck for you, right? Because they didn't have that data copied anywhere else. Okay, so that's a major. Okay, that is definitely a major issue in for those customers. So you have to take care of that. Okay, same thing with disaster recovery. You have, like, imagine, oh, I have some stuff, and now there's an issue with a region on Azure. Hey, you need to be able to rebuild that infrastructure very, very quickly in another region. And then, yeah, the monitoring part, we need to monitor things because I don't want to read a ticket saying, oh, your website is not working, opened by a customer. I want to know it first, okay, by using monitoring tools that will tell me, like, hey, look, your website is not working. I don't want to receive the news from a customer. That's really, if that happens, that's really, really bad. That says that you need a new monitoring solution. You need to review how you're doing monitoring, because you need to know this before the customer opens a ticket and things like that, okay? Because look, for one customer to open the ticket, sometimes that's already down for a long time. and for sure, tons of other customers already noticed and they didn't need anything. Because sometimes that happens with us as a client. I go to a website and I'm like, oh yeah, it's not right. They're probably trying to solve the issue, right? And I will trust that they already know. I'm not going to send a message or open a ticket. I trust, yeah, they already know and they're going to solve this. But if they don't, that website is down for long periods of time until someone notices. And then configuration, user management, automation, scripting, all of that. But today we're not here to talk about security, protection, monitoring, or configurations. We're talking about governance. And we're going to talk about what? Policy management and cost management will be basically our two big things. So let's talk about that. How can we govern the cloud? So we're talking about policy-based management, right? So policy-based management, I can then enforce policies around my cloud environment. Okay, I can do this a little bit more specific, just for one subscription, just for one resource group, but I can also do a policy, basically a company-wide assignment. And we're going to see how we can do that in just a moment. But the thing is, the way that I approach my customers with this is not so much saying, hey, look, you're going to be basically prohibit of doing this, this, and this. I don't like to say, I will deny you of doing this, this, and this. What I like to say is, hey, look, we're going to work together so that we can fulfill certain policies, certain compliance that we as a company, we have. And sometimes that compliance is what? I have customers that we basically have compliance that says something like this. You need to make sure that, okay, your data is not outside a certain Azure region. I have a customer in the Netherlands, for example, that what we have with that customer is something like that. The data, it's a regulation from the government that says data cannot leave the country borders. And so, look, we like it or not, we have to fulfill that. Get it? So we have to. And yeah, we have done it by using policies that states like, oh, you're creating, imagine a resource that is a storage account. Well, the storage account location needs to be in the Netherlands, so West Europe. And we are also saying that you cannot use like methods of geo-replication like GRS and others. You can only use local redundant storage and zone redundant storage. So we had to do policies to make sure of this kind of stuff, so that, because if you use GRS, means what? Means that there's going to be a copy of your data in Ireland, North Europe. We don't want that. Okay, we just don't want that. And so we have, okay, to make sure of this, so policy-based management will be important in here. What about cost management and optimization? We're going to talk about that. That's like the last part that we're going to talk about. But yeah, that's important. We need to monitor our costs so that we can drive what? Optimize cloud infrastructure. And not only do this and monitoring the cost and having careful with the cost, but I also need to take and do accountability for this workload. I need to put this in an expenses of that department, or let's talk about usually more accounting terms, that cost center. There's a cost center within our company, cost center 1 to 3, and that's where I need to drop, okay, the cost of this workload. Oh, the other workload, oh, it's another cost center. Because then in the end, I want to understand how much money I'm paying per cost center. I'm saying cost center. Your company or your customers might be organized in a different way. So there's always a little bit of consulting on this. That's like, okay, this is usually what I do is I give like a workshop on this is the capabilities that we have, and I show them what we can do. And then together with their business, they present their business part, and then together we work in order to achieve the best solution that will fit their business needs and the technical capabilities of the solution that we have. And then that's my job too, okay, to achieve that. But they already understand the limitations and the features that we have. And then, of course, when they also present what they want, we kind of try to basically best match, okay, the two together. Resource visibility. So this is basically what I have to see my resources and what we talk about, and we're going to see role-based access control so that we can make sure that, yeah, you're only going to access the stuff that you need and you do not have over permissions. I'm not going to give, oh yeah, global here, like a lot of permissions, okay? I clearly don't want that. And subscription governance. Every time that I have teams that they are going to say, hey, we need, I don't know, something, we need to do something. I was like, yeah, great. There's a template here ready for you to do this, like storage accounts. I have a bunch of settings that I want to make sure, like soft delete, I need this to be active, encryption in transit, I want this to be active, and things like that. So I want to make sure that all of this is there and is configured in a certain way. And I'm going to do this. I can create just a template. And look, when I say template, it can be an ARM template. It can be Bicep. It can be Terraform, whatever. Okay, I literally not the person to be picky, with this kind of stuff. Choose what fits best for your use case. And then look, you do that. You put that in here, and you're good to go. Okay. So we have that part. This is for a storage account. Then you need to do it for VMs, etc. And you can create a bunch of templates for your DevOps team to use. What about the cloud governance? So how do I start to do this? Usually I start by creating a document in here. That document is going to be my governance approach. Okay. So what I do is, I create a naming convention, okay, for basically for resources. That's important in Azure because and we need to do this per service because storage accounts, they can go, I think is up to 23 shards, I think, or something similar to that. But they all need to be lowercase, doesn't accept like a dash in the name and other stuff. If we're talking about virtual machines, it's different. If it's a Linux VM, I think it can go up to 64 shards if my memory doesn't trick me here. And you can have dashes. So you see, it's quite different, the capabilities that I have in one and the other. So yeah, we need to create like a naming convention for this. When you create, by the way, naming conventions, remember that we also have something called tags. So if you want to put like metadata information around what you're creating, maybe the name is not needed to be there, okay, because you can put that data as tags, or sometimes there are properties even already in the service to have that. So one of the things that I see a lot of people to put is, oh, where is this located, the service? That's on the properties of the resource. Why you put it in the name? And sometimes we have like Windows virtual machines. They have very little space, okay, in terms of number of shards. So we are super limited with the stuff that we can put there. And look, you have to understand all this. I'm not saying that it's right or wrong, okay? Don't get me wrong here. I'm just saying that if it's in the properties, so maybe you can see if that works for you and you don't need to put it in the name, okay? This document of governance, that the approach that we're going to take, usually I have like, oh, it's executive summary. I just explain what the document is about, and then, yeah, then we kind of start to to basically to do, okay, all of this part, okay, naming conventions, creating forms for new subscriptions. It's like, it's normal to have multiple subscriptions. You're going to have multi subscriptions. But my question is, are you going to create every single subscription that people just request to you? Never a good idea, right? So you should, okay, be careful with that. And you should create like a form asking out, why do you need this, and a bunch more of informations around that. And then you will decide if you want to create or not the subscription. So I do this for a customer, and I created a Office 365 form, and then we have Power Automate or Logic Apps in the back that we creates like a workflow around this based on the things. And then eventually it gets to me. And when it got to me, that one, to me approve, I just reached out to the person and I said, hey, look, I understand what you want, but let's just do a 101 short call so that I can really make sure that I understand this. The person said, yeah, no, okay, I got it. I'm not going to create a subscription for you. I'll reject this. But see here, we are using landing zones. There's like a zone here that has a bunch of subscriptions that it's exactly for what you want to use. So just go there and create in one of them. Just ask access to one of them. And if it's not approved, I will approve it. But there's a process internally that, so you should get approved. It doesn't need to get to me. If doesn't, it just get to me. Sure, no problem. But this is why we created this kind of stuff. They basically wanted like a sandbox where you could try out some stuff before you deploy that to development even. But he wanted to just play around a little bit. It's just it makes all the sense, to be honest, what you wanted. But I just don't need to create subscription for that. There's just no need for that. Also document all your Azure policy stuff. Hey, I created this policy. Oh, I got the the built-in policy for da-da-da-da, and I assigned that year, and year. Okay, yeah, great. We know that. And then something that I don't see that many companies and that many customers to do, which is what? Which is creating an incident, okay, an incident report. Because look, if something happens, you need to have some structured way on how to solve this. And I see a lot of people that they just don't have that. A lot of companies that don't have that. The other day, there was an issue with Azure AD. One of my customers in the States, they were like all totally lost on how to solve that. And I was like, really, don't you guys have like an incident response plan? And basically the one of the directors of the company on the IT said, well, we don't, but we are going to get one because we just had talk about this the other day. And he said, yeah, when you talk about that, I was like, oh, damn, we don't have that. But I didn't want it to say anything. And I wanted to do this. But I think we need to talk. And yeah, we're doing this for them. Which is, if this happens, how and who needs to do stuff? They didn't have anything. Okay? And this is not a small company. Okay, it's not only as a very large company, sure, but they still have quite a few seats. Okay, so we started with subscriptions, right? So let's start with subscriptions. But even before subscriptions, let's talk about regions and what is a region. Okay, very easily, a region is a set of data centers. Okay, all the data centers are in the same country, and we have a bunch of regions worldwide. But now, let's talk about certain things. Is that not all the services are available in every single region. So I can show you this here. The other day, I was doing for a customer. Okay, I was basically it's about dedicated hosts, and they wanted to create dedicated hosts. Okay, in Norway. There's this amazing website. Okay, that's called. Just search Azure products by region. You should get in here. And hey, what is the basically what you want to search? Azure dedicated host. And you scroll down, it's going to show up in here, and you see there is no dedicated host. See, for Norway, it's empty. There's nothing in here. So yeah, sure, it's not in here. Period. Okay. So you cannot use it, and this is just an example. You have plenty of others like container registry. I think it's also not available. This one I'm not sure. Let me see here. No, container registry is, but well, other stuff that is not. I think AKS maybe. Let me see. Yeah, it's Azure Dev Space. Oh, well, that doesn't matter too for them. But well, there is other stuff that you have to be careful. Okay, that might not be available. Okay, for your regions. And look, you have to be careful with this kind of stuff, right? Because if something happens, you need to be there, and you need to be able to solve this kind of stuff. Okay, so there you go. So we have a bunch of regions, and if we zoom, okay, here, for example, in Europe, we can see, yeah, plenty of regions, and most big customers and other smaller ones in Europe, they already have basically the regions. Okay, so we have here Italy, Germany, Austria, Poland, Germany, Denmark, Sweden, blah, blah, blah. A bunch of them. Have we have regions everywhere? No, there's a lot of customers that are missing regions, like Bulgaria being one of them, that we still don't have it. But in Europe, we have this because we have a lot of regulation per country. So my view, what I would like to see, and look, I don't know anything about this as an MVP, zero. I have like zero knowledge on this, to be honest. I would like to see every single European country with at least one region, to be honest. Will it be there? I think so. At least we see some countries here that are small to getting regions. It will take a while. Oh, sure. I don't have any questions on that. It will take a while. And so we need to wait quite a while to get something like that. But that will be a dream for me, for Europe, to have one region in every single country. That will be pretty cool. What is a subscription then? Let's talk about subscriptions. A logical unit of Azure services. And usually those subscriptions, okay, they are connected here on top. We have here Azure AD. Okay, so this here Azure AD, and I'm writing with my mouse here, so bear with me, okay. And so this Azure AD, it will be here. It will be connected there and there. And this Azure account, okay, it's basically a user that exists over there. And then look, one subscription is connected to one Azure AD, but one Azure AD, okay, can be connected to 1, 2, or 3 subscriptions, or more, or just one, or none, even. Okay, so that can be possible. When I do role-based access control in like this subscription here, I'm getting the users that are of the Azure AD tenant that is connected. This is why I only have one Azure AD, basically, with that subscription. Okay. Sometimes those subscriptions are an easy way. Well, not sometimes. They are always an easy way to be what we call a boundary for security, because we can do role-based access control at the subscription level. So I can say, hey, you can be contributor on that subscription, but on the other one, you're just a reader, and I have like 20 more that you don't even see them. And it's easy. It's a very easy boundary, like a folder in a file share. Yeah, there you go. It's done. You have access to everything inside. So all the resource groups or not, if I give you proper access, the access that I will give, it's kind of the same thing. It can also be a billing boundary. So I can easily take reports from the billing structure, like, oh, how much money did I spend on that subscription? Oh, you spent 30,000 euros on that subscription. Okay, great. It's easy to understand. Do I agree with that approach? Maybe not. There are some concerns with that approach, especially in the infrastructure as a service world. You might, put some stuff there, and then, like, imagine you have 10 subscriptions, one for each business unit in your company, and I have some VMs here, and all of them have virtual machines. If I have virtual machines in one subscription, I need at least one VNet. But then sometimes, those virtual machines, they don't exist by themselves. They need to talk with on-prem. They need to be available so that other VNet, other machines in other VNets need to communicate with them. So we need to create some kind of connectivity between VNets. And this was the case in one of my customers. So they were paying a lot of money for peering. And they had a very complex peering infrastructure, I have to confess. So we revamped the way that they were doing this so that we lowered the complexity. But look, this might work for some companies. I'm not saying that it doesn't, okay? It's not a solution that fits all of them. Then we have this, is just to talk about that. Yay, we have a bunch of different subscription types. Great. Different capabilities sometimes, especially like billing APIs, and how can I reach there with a cost management tool? Not all of them. So just be careful with that. Don't expect that, oh yeah, I will go for this one, and it doesn't have any consequences, because it has different capabilities, different things. Just be aware of that, and query, okay, your partner when they are doing or Microsoft when you're before you select. I will go for that subscription model, okay. And then in the end, we have several subscriptions: 20, 30, 200, 1,000 subscriptions. We need to find a way to manage those subscriptions. And that's management groups. So I can do management groups. And management groups will provide me a hub per layer, okay, or scope, in terms of my subscriptions. I have my subscriptions in here, and I have all this scope here that has a hierarchy, can have 6 levels, can have 10,000, okay, management groups here. So we have a lot of stuff here that we can do. And all of this, okay, that we have here, we can, we basically can create like an hierarchy where we can group, okay, subscriptions. And then, yeah, we can take care of them, and we can take policies up to and add a policy in the resource group scope instead of have to do it per subscription. And I can have one management group here that hosts 10 subscriptions. So if I do policy on the management group, all those 10 Azure subscriptions will be impacted now with that policy. So that policy now will be to guarantee whatever it guarantees under all those subscriptions. Management groups can also be a scope for your billing. So if you go to the cost management analytics tool, you can also use this to get into the basically as a scope, okay, to understand all your costs and analyze the costs, etc. Benefits that I see with this: logical representation of your organization, and I can apply policies at the management group. and I can do governance over my subscriptions. Okay, so let's just do a demo here, which is a walkthrough maybe into my my Azure. Okay, my Azure subscriptions. Okay, so let me open here the Azure portal. It's in here. Let's go here to open the Azure portal. Okay, and it's a little bit slow today. Okay, and there you go. If I go to management groups, so you might see a different UI here if you didn't open management groups for the past weeks. So yes, there is a new UI in the house. Basically, Microsoft released this a couple of weeks ago, and now we can see a hierarchy of our management groups. And you see here, I have my tenant root, I have my AZ Contoso root, then I have here others, I have here corp branches, and in branches I have North America, Europe, etc. And you can see here the number of subscriptions that I have inside. Okay, so if I open here like Europe, you can see here, oh, Europe, look, this is the ID. I have 4 child subscriptions. I can click here. I can see my subscriptions. You could also click here on the left under subscriptions, and you can see I have the AZ Contoso DE and L, so Germany, Netherlands, Portugal, and the UK. So I basically kind of created one subscription per country in my demo environment in here. And I can do policies in the management group, or I can do also access control, okay, at this level. So if I click here in the access control, okay, I can just say add role assignment. It's the usual stuff, but I'm doing this at this management group, the Europe management group. And I can select here like, oh, contributor. I can say here, hey, AZ Contoso training, and I can press save, and there you go. Okay, failed. Oh, the role assignment already exists. Sorry, yeah, because I already did this. So let's just put this as not contributor, but as reader. Will it work, reader? Let's just see if this one here works. Okay, reader. There you go. Okay, so now he is a reader. And now look, of course, look, if I open in the private window, and if I open portal.azure.com, and by the way, this user I will use here. This is a FIDO. Just put this like so that you can focus. Okay, it's a FIDO key. So I'll just say here, hey, I want to sign in with a security key. It's just ask, hey, open, put this in the USB port. Yeah, I'm going. It's there. Touch your security key. I will do this, and there you go. Okay, we are connected. So I can connect this without a username. And if I go to subscriptions, you can see here, it doesn't show up there, but I can say resource groups. I can say, hey, let me add a new resource group. And if I click here, see, you can see all the others, but I didn't give permission to each one of the subscriptions isolated. Okay, so I didn't do this. And if you see here, this is my global admin now account. And if I go to subscriptions and I open here the AZ Contoso Portugal, okay, and if I go to access control and I see here check access, okay, so if I say AZ training, okay, so I find the user, and you can see that, hey, you have this here, okay, a role assignments, those two, because the contributor already had, now I have reader too. And you see the scope is the management group, and it's being inherited. Okay, so you're like, oh, okay, basically now you know that why that user has permissions in here. Okay, so this is it. Just a small, and look, sorry, I didn't explain this. It's like just quite obvious. Management groups. If you want to create a new management group, imagine that I want to create a management group inside branches. Like imagine I also want to do Africa. I go to branches, I can click add, and now I could just say, hey, Africa, and this will be 124. Okay. Oh, sorry, just the opposite. 124, and then the display name Africa. And then I could do this, and a new one will show up in here. Okay, so we could do something like that. I'm not going to do this, but yeah, that will be the idea. So what is the next slide? The next slide is about Azure policies. Okay, and we talk about Azure policies. I talk about that I can create, assign management policies. I can run evaluations so that I can check non-compliant resources. And what are the advantages of this? Well, I can enforce compliance, I can apply compliance policies at scale, and I can do remediations. Great. What can I say with this? So imagine the following. I have a policy, internal policy that we just defined that says this. Every time I create a virtual machine, I need to have backup, okay, enabled. It needs to have Azure backup. So, okay, great. I can do that. I can create a policy that will be an audit. So the enforcement will be just audit. And it will check all the virtual machines, and it finds 1, 2, 10 that are not. They will just mark those resources as not compliant. And like the name says, is audit. Okay? But look, I can also do something a little bit different, which is what? Which is I can, okay, do a deny. So the enforcement can be a deny, which is if you try to disable that from a machine, it will not work. If you try to create a new one without this enabled, it will not work. Okay. What about remediation? So I can even, and this is not as simple. You need a managed identity to make this work with the right permissions and things like that. So that part is guaranteed. That I'll just say every time I create a VM, you have to enable. If it's not enabled by the creator of the VM, you enable it. Maybe maybe not. You are going to need an Azure Site Recovery. So if there doesn't exist, you can even create that yourself. So we can have this remediation, and we can have policies to do this. Other usage on policies is a little bit more simpler. Might be allowed locations. I want to make sure, it doesn't matter why. I want to make sure that my resources are created in a certain location. We can do a policy with deny. So it doesn't even allow you to create that. Let's just see that in action, by the way. Let's just get in here. And look, I already have, by the way, a policy working in this subscription. So if I go in here, let's imagine I want to create a storage account. And I say to my storage account, hey, I want to create a storage account where? In the AZ Contoso UK. I choose a resource group, doesn't matter. I just put here a name. And I'll leave this as East US. I have a policy on this, and you see this running it failed. Because if I click here, you see, oh, there's that policy that says that this is not working. What that policy says, I'm not going to open the policy just so that we don't steal time from the presentation, but what it says is that the region here can only be one of 2 regions, the 2 that are existing in the UK. So I need to choose one of the UK regions. And if I do review and create again, validation passed. Got it? It didn't even allow you to create this because the effect on this is denied. So if we go back and you go here to policies, you can see policies here. And if I go to definitions, I can see a list of existing definitions. There are hundreds of built-in definitions already in here. And look, this locations is an easy one. It's an obvious one that everyone needs. So Microsoft already built this one for us to use. So there you go, allowed locations. And you click here, you can see the policy definition. The policy definition is what? It's JSON. And I'm look at this and I'm like, oh yeah, great. So I have this, and then look at this part. The effect of this is deny. And then you just see here, there's a parameter with all the regions, and yeah, this will show all the regions. So you know that you have to choose and pick the regions where you want to allow this stuff to be to be created. Cool, right? It is pretty awesome, the stuff that I can do with this. Then I have assignments. So this is the definitions, right? But I need to assign this. Okay, now this is not refreshing. How cool it is, huh? Oops, I think I touched the wrong button. Let me open again. Let me go to policies again. Let me go now to assignments. There you go. There you go. I can say here, hey, assign a policy. And the assignment of the policy is really easy. You just need to say, hey, what is the scope? And I can say, hey, Europe. Okay, that's the management group. And now, what is the policy definition that you want to put here? And you see, we have 643 different policies here. So I'll just search for locations, okay? Oh, allowed locations. There you go. And you just touch here, okay? There you go. And now you can put a description. You can put an assignment name, blah, 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 etc. And now you just need to say parameters. What are the allowed locations? And you're like, I can just say, I don't know, Southeast Asia, India, this one, this one, this one, okay? And then I can just say review and create. There you go. Or remediation, see the remediation part in here. Okay, like I was saying. And then yeah, review and create, and there you go. Okay, I could now create this. I'm not going to create this, but you get the idea on how to do the assignment. Of course, look, I did this in the Azure portal. And yes, you can do this by using definitely by using what? By using PowerShell, Azure CLI, and all of that. Yeah, sure. What about cost management? So we have what I say, it's the obvious tools. Pricing calculator to understand how much you're going to pay. Okay, you have the Azure Migrate that basically will tell you, yeah, how much you're going to pay with that migration, even helps you to choose some of the destination VMs and things like that based on how much you want to pay and things like that. And then all the other migration tools that we have, like the Azure Migrate, okay, the app service, blah, blah, all of that. But before we start even and we advance a little bit more, we need to understand one thing, is that managing costs, we always have different actors on managing costs. We have IT executives. An IT executive, it has a view that's definitely going to be different than the financial team. Because the IT executive needs to understand, yeah, okay, how much money I'm going to spend on this? Will I have a return on investment in my spend? It doesn't matter. It doesn't care if he has to spend 3, 4, 5, 10 million. If he has a return of that money back, oh, great, let's just do that. He wants that, right? A financial team, what they need to know is, okay, we need to guarantee that the forecasting for spend will be fulfilled. I have things that says like, oh, I'm going to spend 100K this month. That's what I'm saying. Great. I need to guarantee that I'm not overspending. They have to manage cash flow in the company. It's not easy. Definitely not easy. Because we work in a base of assumptions, and if something fails, we don't have the cash flow. Like, oh, we're going to sell 10 million euros this month. So we're going to have 10 million in revenue. And in those 10 million, we're going to get 8.5 during the month in our bank account. And then the rest it will get in the next month. And we're like, okay, great. They are counting that. They are going to have 8.5 million to pay stuff, right? To pay goods, to pay it, to pay Azure. So they need to know that's their goal. And then we have project teams that they are just in their tiny silo where they need to understand, this is our project, this is how much money we're going to spend, and they need to find ways of re-architecting, re-engineering their project so that they can still have an awesome project, but cheaper, and run it cheaper. Tags they are a great help in all of this. Okay, so I can use tags to make sure that this will help me, etc. Here, what are tags? Tags are just name value pairs. What kind of tags do you use, Tiago, all the time? Oh, definitely cost center, environment, who is the owner of this, and then some others, but at least those are like the bare minimal that you should have. With this, you can do questions, okay, in here to this CSV file that is super detailed, and then you can have other tools and you can make queries on those tools, like the cost management tool that you have on the Azure portal. How much money did I spend in production environments? How much money did I spend in, for this cost center? And what about for that cost center, but for development, and that cost center for production? And then look, with Power BI, we can build like super cool, super cool things, etc. Like if I show you here, Power BI, in Power BI, let me see if I have this in this Power BI that I have in this machine. I'm not sure because I had to rebuild. This is I don't know if Power BI was updated yet or not. But if in Power BI, you just do the get data, feature. This is still, I think it's still loading something, there is, there you go. So get data, and if we choose the get data bit, it's still loading, Azure, and somewhere here in Azure, there's like a there we go, Azure cost management, and this basically gets the data from the Azure cost management utility. So you can literally get tons of data from there, and then just analyze your spend and all of that part. So it is quite cool, the stuff that I can that basically I can do with this. It is quite cool, the stuff that we can do with this. Savings. How can I save money? Well, definitely using Azure reservations. Azure reservations are not just for virtual machines. There are plenty of services in here, but imagine virtual machines. Let's give that example. I have a workload. I'm sure that this workload will still be here in 3-year time. And I'm like, yeah, great. So let me do a reservation. 3 years for those virtual machines. And I can get savings that can go up to like 58%. If I'm migrating virtual machines from on-prem, and I have an enterprise agreement contract with the correct licensing to make this work, there is something called the Azure Hybrid Benefit, which states that you can migrate licenses from that contract and use them in Azure. Again, huge savings in here because you're not paying the license of Windows. Again, this just doesn't make any sense. Or SQL Server. Azure credits. Yeah, Microsoft could just give you some Azure credits for you just to try out something, etc. That's another way to do some cost savings, Regions. There are huge differences in price between regions, I already had this example in the two different ways, So one of my customers, they were using Switzerland as their region, okay, for basically for running their stuff. And see, you're Switzerland West, and this is in British pound. Let's just change to euros. There you go. And they were paying this amount of money. Let's see, okay, per the first 50 terabytes of storage. This is the storage bit per gig. And I was like, okay, but you guys have some regulation on this. And they're, oh no, we just chose that one because it's near us, latency, da da da. I was like, hey, what about West Europe? Is it West Europe good too in terms of latency? Oh yes, it is. And you see the difference in the price here? It's like 1 cent less. It's like 40%, okay, or something near that of savings. It's a lot of money, really a lot of money, and it's not just in storage. In other places, the difference is not 30. Sometimes it's more, sometimes it's less, but it's always more expensive, okay, over there. So you have, okay, that, and look, you have to be careful with this. So this can be a great way of saving money, okay. And then look, Azure policies, you forbid the creation of certain resources, certain SKUs. You can always help you to save this, and then do monetization on your virtual machines. Do you really need a VM at that size? You just do this with a smaller one. Azure reservations, spot instances, the regions, and use dev and test subscriptions. Dev and test subscriptions, they can be cheaper because you don't need to pay the license. And if you're doing dev and test, they can be great for you. So this is it. So thank you very much. My name is Tiago Costa, and this is how you can govern Microsoft Azure. And I think I'm right on time.
Days. No matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? There's a partner that can set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
start my days. Sun rays, I tap the phone. Coffee's on, I mow the lawn. Impressing Sean, so connected, so effective. I let it drop, clean it up. Heated smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch with many connectivity solutions for a smarter future. From Bosch.
Datavard is a global software engineering firm that takes a uniquely human approach to solving problems. With over 20 years of experience, teams of highly trained engineers around the world, deep industry sector knowledge, and ongoing technology research, we help clients create custom software that improves their operations and opens new markets. We integrate our engineering excellence with deeply human values that drive our business and our approach to relationships. Curiosity, empathy, trust, honesty, and intuition.
Hold up.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
These days, if you don't have an app, you're falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there's a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Inhill, you imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, they're watching me. IoT, 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 IoT. I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch with many connectivity solutions for a smarter future. From Bosch.
Datavard is a global software engineering firm that takes a uniquely human approach to solving problems. With over 20 years of experience, teams of highly trained engineers around the world, deep industry sector knowledge, and ongoing technology research, we help clients create custom software that improves their operations and opens new markets. We integrate our engineering excellence with deeply human values that drive our business and our approach to relationships. Curiosity, empathy, trust, honesty, and intuition.
Hold up.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Okay, welcome. Good afternoon, everyone. I guess it's my turn, 3 p.m. Again, good afternoon, good evening, good morning. We are global, so I guess we have to be inclusive. Thank you very much for joining my session. It's, I guess, going to be an interesting one. We'll have to go through a bit of history, then we'll see what's the current state of affairs in the data warehouse world. And I'd really like to share with you what's going to be the future as things are developing. But before we get started, I'd like to introduce myself. My name is Ivan. I'm an MVP in data platform. I'm also a certified expert, and currently I work in the World Bank Group here in Sofia, the shared services center that was recently opened. I spent my career working for companies like HP, Microsoft, Inspirit. I had my fair chance to work in customer service, as a consultant, as a support guy, basically doing anything that has to do with data, and primarily in the Microsoft world. So what's going to be the agenda for today? I'm going to start with, so before we get to the lakehouse pattern and what actually it means, I want to get through the history and the evolution of data analytics systems and how it originally started, what was this thing called data warehouse, what are the core properties for a data warehouse, Then we'll switch to a data lake, something that emerged, let's say 10 years ago or something like that. And lately it's been hugely popular with organizations. And I'm talking about data lakes and data oceans, not about data swamps, but let's discuss this in a couple of slides. And then I'd like to discuss and share the concept for the data lake house. So how the data warehouse, the data lake, and other technologies actually evolve, and how they create this new paradigm that we all have to more or less adopt in the recent future if you want to scale and use our data as we are supposed to. And then I'd like to share some of the data lake and data warehouse patterns and how to move from them and move to a lake house pattern. And what else? What's going to be not the next step, but the step after you are in a lake house pattern in your data warehouse? So all those things I'd like to cover in the next 60 minutes. I really love if I had the time. We'll have some time at the end for questions, if time permits, of course. If not, I'll share my contact so we can discuss things further. So without any further ado, let's start with the first topic. So what is the data warehouse? The data warehouse as a concept emerges. So it was like before I was even born, in the 80s of the last century. And generally, it's a system that is used for reporting and data analysis that is considered a core component for any business intelligence solution. A key here is that data warehouse is different than business intelligence. People are often confusing them. The data warehouse is not a business intelligence solution. We don't have the time to go over the difference between those, so let's just stick to the data warehouse part. So the data warehouses are central repositories that contain one or more different data, that contain data from one or more data sources that are brought in using an ETL process, extract, transformation, and loading process. Within that enterprise data warehouse, you collect historic data so that you can create descriptive and diagnostic analysis. So what happened in the past and why eventually it happened. But with data warehouses, it's really difficult to answer questions, okay, what's gonna happen, or what to do in order for this not to happen. So predictive and prescriptive analytics. So this is a first major kind of a limitation for the data warehouses, but let's pause here and go back to the concept for the data warehouse. So you have this enterprise data warehouse. There are different types of architectures, hub and spoke enterprise data warehouse. You have the data mart kind of per business unit structure. So different variations, but generally they're all the same. They contain copy of your line of business data, and they present it to a front end, usually a business user or a unit, or eventually, eventually a reporting solution, something like Power BI, Excel, reporting services, Tableau, and everything out there that can talk to a relational database engine. So this is the first actually key thing. The data warehouses in the past and how they were built were structured data warehouses. They contain structured data. You have to know the schema before you enter any data in that data warehouse, before you land it. So this is the first thing. The second thing, because it needs to be relational and structured, it is a schema on write approach. Then you have to scale it. How do you scale it? It's a monolithic system. You have to either buy more memory, more storage, more compute power, or you try to scale it with some kind of a hub and spoke type of architecture. But that was very difficult, and not only that, but it was also very expensive. But in the beginning, things were okay for the first probably 10, 20, even 30 years, data warehouses are doing really good, were doing really good. They are still doing really good, but for limited use case scenarios in the organizations. So 10 years or 15 years ago, big data scenarios start emerging. You have sensor data, you have logs, you want to make sense of all this huge amount of data. So distributed systems came into play in order to support those scenarios. But the traditional data warehouse couldn't support this. You can't create, or it was extremely difficult and expensive, and then difficult to manage, to create a data warehouse that can accept big data type of scenarios. And then first, because of the volume, second, because of the velocity, and third, because of the schema changes and the variety of data that comes in. I mean, you can't afford to get to insert a corrupted file or a file with semi-valid data in your data warehouse. It was very difficult to manage. Then, what are the other properties for the data warehouse, traditional data warehouse? You have ACID compliance, so you have transactions, you have insert date delete statement supported. It's a single layer of store and compute, meaning that it's most of the times and most of the implementations, the data warehouse is just a bunch of hardware that is a single server or distributed kind of a scaled out servers that are serving different purposes for different marts or analytic tools. But generally, wherever is the data, there is also the compute. So they are stacked together. They are not separated. You can't scale them separately. As I mentioned, it's covering descriptive and diagnostic analytics scenarios. So what happened in the past? What was the reason for this to happen? But nothing more. And it targets. So the data warehouse usually targets operational users, report users. It's not really useful for self-service scenarios where people can drag and drop. You need to know the schema of that backend. You need to know the structure of the data and so on and so forth. But it was really easy to satisfy thousands of connections. So you could easily hook up 1,000 users, as long as you, of course, have your performance tuning in place, proper indexing, proper structures, partitioning, and so on and so forth. So that was the data warehouse. Then, as I mentioned, the big data scenarios came in, and the need for storing huge amount of data that didn't necessarily have a fixed structure, and data lakes emerged. So what is the data lake? The data lake is a system or repository of data that is stored in its natural format. So whatever has been emitted or created on the source, this is the format that is being stored in the lake, being that a JSON, a CSV, an image, a streaming media, or even a streaming kind of pipelines, like Kafka or IoT hubs or IoT data and so on and so forth. Within the data lake, the data lake is purely a storage layer. And it not only contains the raw data, but it also contains duplicates of that data that has been transformed to make more sense for the business users, that is transformed to make sense for better querying, that has switched formats so that you can follow some kind of a standard. But again, this is just for storing the data. There is no compute at this point. What are the key properties for a data lake? You can support all kinds of data types, as I mentioned, structured, semi-structured, unstructured data, whatever you need. The schema reading or schema governance is basically schema on read. You don't have to know the schema in advance to lend some piece of data. But you don't have ACID properties. You can't have atomic transactions. You don't have consistency. You don't have isolation, durability, things like that you don't have in the data lake. It's just a blob. It's just a file. It's like having a folder on your laptop and trying to create a transaction where you delete all the files. It simply can't do that. Then, well, originally, now modern kind of technologies or services allow some of those things to be covered, but still not fully ACID compliant service or pattern. It's cheap and scalable. The storage in Azure particularly, you can store terabytes of data in just less than $500, which is pretty cool. And then it's also scalable. If you need another storage account or if you need replication across a continent so that you want to make your data available to others, you can do that easily and natively with Azure storage accounts. What kind of analytics scenarios? Because the data lake stores all kinds of data and it doesn't have any limitation on the variety and volume of the data. Besides descriptive and historic kind of analysis, you also have predictive and prescriptive. So you can hook up AI, you can hook up machine learning, you can hook up all those scalable additional algorithms that can make sense of your data. It's targeted for data analysts and data scientists. It's not for the regular user. You need, in order to work with the data lake, you need a huge compute layer. So you need something to do the computation. So you have the storage, but if you have a user or a use case that says, give me all of the details for that files or give me all the content in that particular file or folder, well, you need a compute layer in the middle to do the actual job. So the compute layer is actually very important, and it's something that is very often missed in original planning or in end user scenarios. But, and then one very important topic before we dig into the compute layer, the last very important property in the data lake is that you don't easily achieve updates, deletes, or inserts upserts, if I may, to your data. So whatever you land there, you either delete the whole blob with all the lines, or you just append constantly files. This is the only pattern in the data lake that's been largely supported. If you want to achieve those things, usually you have to take the data, move it to a compute layer, usually a Databricks or use a Databricks or Synapse Analytics or Azure SQL Data Warehouse, the former name of that service, and then try to make something like staging and deltas and so on and so forth. But that introduces a middle compute and store layer to handle this. Now, if you need to compute on top of your data lake, you have basically two options from looking at it from ego's perspective. You can have SMP or MPP architecture. So basically single processing, where you have a single hardware with single compute and storage combined in the same unit, or you can have massively parallel processing systems or MPPs. So we are in the Microsoft world right now in this session, so this would be a SQL Server or a SQL DB if we talk about SMP, or if we talk about MPP, this is APS for on-premise analytics platform system, or Azure Synapse in the cloud or Databricks. How this compute layer on the MPP angle looks like? So you have a single control node. If you look at, for instance, this one here, just a second. So this is a compute node that accepts all the requests from your users, being that analysis services, being that Power BI, being that individual queries, or anything that needs a result. And it distributes the computation across multiple nodes. So the computation itself doesn't necessarily happen within a single node, which was the case with the SMP architecture. A very key thing here, with SMP architecture, you have to actually copy the data in in order to do any manipulation or querying. With MPP architectures, you have two flavors. If you're doing Databricks, you can just use querying using Spark APIs or Spark native language or Python or Scala or R or whatever to query the data, and then the Spark node would talk to the storage and work with that storage to bring that data in. This is the Databricks and Spark kind of cluster environment. If you have an Azure SQL data warehouse or Synapse pools, you will have to bring that data in, usually using Polybase. So you can't effectively query the data. Well, you can create external tables and so on and so forth, but that doesn't necessarily mean good performance. So with MPP architectures, the compute layer, Databricks, or Azure SQL data warehouse. Now, this is the compute, so that's fine. But most of the compute layers have limitations primarily on how many users can run queries in parallel, how many users can connect, and how many, what kind of security I can pass down to the data lake storage. Because essentially, when you connect, it's very difficult when you connect your data, your storage, your data lake to either Synapse or Databricks. It's very difficult to do user owns data scenario. So it's very difficult to pass down the path, the credentials. There are ways, but there are a lot of limitations with those ways. So what usually is being done in those cases, when you need to scale your data, you take the data from the data lake, you take it inside a compute layer, do some kind of data mashup, modeling, create a dimensional or snowflake model, Starsky mode snowflake schema, and then push it to a caching layer. So usually in the Microsoft world, that is Azure Analysis Services. And the purpose for that is to get users in and hit the caching layer rather than hitting the compute layer, because scaling users on the compute layer with Databricks and Synapse Analytics is difficult, it's expensive, and has a lot of limitations. For instance, in Synapse Analytics, you can't have more than, I believe, 1,000 around 1,000 connections, and not more than 128 sessions in parallel, workers in parallel. And that's the expensive option. If you go with the lower tiers, you have even smaller limitations. So you have the data lake, you need your compute layer, and most of the times you also need the caching layer. That is the entry point for your users and reporting. If you have data analytics scenarios like machine learning and AI, they can skip the semantic layer and talk directly with the compute layer, but those are usually data scientists and data analysts that need to explore the data, need to use the huge scale-out compute rather than individual, very quick type of transactional, aggregational type of QAs. Okay, so to summarize, data warehouses, you have sources, you have to be very picky on what kind of data you will get and what is the schema of that data. Use ETL to adjust that data and land it in a data warehouse, usually in different data marts, and then use those data marts with or without a caching layer to create reports, have business users, self-service analytics, and so on and so forth. Here you have a bunch of hops of the data. You have the source, you have the ETL, then you have the data marts, and then if you have a caching layer, that's another hop. And if the caching layer doesn't necessarily is not being used as a live query or direct connection, then you have another hop for the data until it reaches the front end. For instance, if you need to refresh a Power BI data set, you need to make practically a copy of that data in the Power BI service. So you see how many hops of data, and you see why streaming is not really efficiently supported in this pattern. Then the next pattern is the data lake pattern. But again, you land any kind of data, but you lose the ACID capabilities, you lose the DML capabilities. Yes, you have streaming data. Yes, you can implement Lambda architecture, you can implement Kappa architecture, you can do all kinds of interesting machine learning and AI scenarios. But in the end of the day, if you have to do reporting, you still have to do a lot of data copies using ETL or ELT approaches. Finally, here's where the lakehouse comes in. With the lakehouse, the ELT angle and the data lake angle are practically combined. You have a single layer where all the data is being stored, but it's also manipulated. So you only need to get that data there. From this point forward, everyone that needs to connect to that layer just uses whatever compute they have at hand and use that data. Key properties for the lakehouse in a bit. So you can see how we are practically removing the ELT or couple of hops of data before it travels from the source to the final destination. But still, there are a lot of things to happen before it's really used or usable for the end user. All right, so this is the lakehouse. What are the key properties of a lakehouse? First, it is ACID compliant. Whatever you do on top of the data in a lakehouse is ACID compliant. It's atomic, consistent, isolated, and durable. What each of those mean? Atomic means that what you take as a job and submit as a job, it's gonna complete as a single unit. It's not gonna it's not gonna do just half of the work. Then consistent. Whatever operation you're doing, it's going to be consistent. It's either going to complete the whole thing or it's going to roll back. It will not leave data in a funny state that is not supported by any of the constraints that are on top of the data. It's isolated. Isolated means that if I start doing something on a piece of data, no one else will be able to do anything but potentially reading on that same piece of data, which is a very common relational database scenario, but not necessarily something to achieve easily on the data lakes. And then durable, meaning that whatever I did, it's going to stay there, no matter what happens with the platform. As long as I have committed the operation, the transaction, then that data stays there. It can't get lost just because, for instance, the computer restarted and it was sitting in memory and not hardened on the hard drive. These things cannot happen. Second, the data lakehouse should support schemas and governance. You should be able to have constraints. You should be able to have schema, like what's the field name, what's the field type, and most importantly, to be able to evolve that schema without the need to go through lots of either reverse engineering or regression testing, just native schema evolution. The third very important property for a lakehouse is that it should support direct connection from BI tools. Not necessarily hugely scalable tools, but BI tools can directly connect to that data warehouse without that data lakehouse, without interrupting normal operations. Another very important property for a lakehouse: storage and compute should be separated. So storage is one thing; it can scale on its own. Compute layer is another layer that again scales on its own. It should be based on openness. Open standards, open communication, So it shouldn't be a locked-in system which communicates only with one set of inputs and outputs. Basically, the lakehouse should allow any data producer or any data consumer to just jump in, take the data, or flush the data that they have and use it later on. It should support multiple formats and ingestion mechanisms, not only CSVs, not only structured data, but structured, semi-structured, unstructured. All the properties for the data lake, but also support and streaming data and reading of streaming data natively. Not necessarily implementing Lambda architecture or anything like that with additional services. And we have support for diverse workloads. We don't support only streaming workloads, only OLTP type of workloads. The data lake should be able, the data lake house should be able to support also analytics, machine learning, big distributed data scenarios, and so on and so forth. It should allow end-to-end streaming. And by this, I mean from the streaming source to the streaming report that shows the data. This is what end-to-end streaming would mean in this case. And finally, this is something that I added on my own, not necessarily part of the data lake house concept, but metadata discovery and governance. It's kind of implied in the schema support and governance topic that we discussed earlier on, but I wanted to kind of separate it from all the others and bring your attention to it. Because metadata in such a lake, so imagine that you have a vast place where you just dump any data. If you don't govern it, if you don't know what kind of data you have, and if you don't manage it properly from a lake house or from a data lake, it will become a data swamp. And there was this, I think it was a research made by Splunk that says that more than 55% of the data that organizations own is dark data. They just collect it. Can you imagine 55%? So like basically this is half of your data. You're paying for it, you're storing it, but you're not using it. And it's called dark data because you have no idea either that it exists or you know that it exists, but you have no idea what to do with it because you can't access it or there is no easy way to access it. So whenever you build a lake house or any data lake pattern as a matter of fact, you have to have a very stable metadata discovery and governance. And there are things that can help you in that way because I know you probably say, okay, we know this, but we have no idea how to achieve it. Well, there are ways to achieve that, not necessarily by using third-party tools or huge development or invest in huge development efforts. But we'll get there. So let's get back to the data lake. We have the data lake, we have the compute layer, we have our users, we know all the properties of a data lake. How the data lake is actually implemented, or what are the needed layers or steps or changes that need to happen in order to get to a lake house pattern. First, you need an open data storage. At this point, data lake house you can easily implement by using Parquet format. Parquet is developed originally by Apache. You can use it in with Databricks, or actually with any Spark compliant software or a platform or a tool. So this is the first thing. Whatever you do in your data lake, store it in Parquet. And then something that was recently released, I think 1 or 2 years ago, and that is the data management and governance layer, which is called Delta Lake. Delta Lake is now all owned by the Linux Foundation. They are developing it as a standard and as a platform, and there are a couple of tools or platforms out there that currently support it. One of first of all, anything that is Spark-based supports it, which is Databricks, Synapse Analytics, Data Factory, and so on. I'm not aware of the AWS services, but you can imagine where the story goes. So you have the Parquet format. You have the data management and governance layer, which is the Delta Lake. What exactly this gives you on top of the data lake? First, the Spark part I forgot, but yeah, if you wanna go to a data lakehouse pattern, most probably you will have to use Spark as an intermediate compute layer. So what do we get with the open data storage, in this case Parquet, and data management layer, Delta? First, we get ACID compliance. The Delta Lake format and together combined with Parquet can give you the ACID properties you need and that were missing in a data lake. So the Delta Lake supports time travel. It creates a log or versions of the rows whenever you insert, update, or upsert or delete data. So you can definitely go back in time. It's durable. You have now the transaction concept on top of Delta Lakes. And you can, as I mentioned, you can do deletes. And if you do proper partitioning, you'll be also able to do fast query searches. But still, this is a file-based system. It's not necessarily entirely in memory. So you will have to think how you design. Partitioning is a key thing when we talk about data lakehouse design. You need to think how you're going to partition your data, what are going to be the partitioning fields, what is going to be the size of the data. And because it's a distributed system, you won't necessarily write in a single file. You might end up writing 100,000 lines in 1,000 files, 20 megabytes each. That is not useful. When we talk about data lakes and data lake houses, theory varies, but generally you want to keep your files somewhere between 128 megabytes and 1 gigabyte. Not more, not less. Why? Because the distribution units that work on the data movement and data computation are actually separate, most of the cases, Java virtual machines or some data stores in data lake that have limited capacity. So most of the optimization patterns for data lakes and data lake houses contain this guidance for first partitioning and then file management. All right, missing anything. So let's see how we can evolve an existing data lake to a data lakehouse pattern. So first, the data lake in Azure is Azure Storage Account Generation tool with hierarchical namespaces enabled. You have POSIX permissions. So there is no other service that can provision this kind of behavior. So if you want to build a data lakehouse in Azure, you can go with Azure Storage Account. And that's the only thing that you can use at this point. Then the data management and governance. Whatever you write with that on that storage account in that data lake needs to be in a Parquet format, and it has to be based on Delta format as well. So Delta currently is understood or can be used with any Spark-based service, which leaves us with 3 different options for the compute and front end: Azure Synapse, Azure Databricks, and Azure Data Factory. All of those are kind of a high-code type of tools. So they're not useful for end users that have never written queries or that are used to do drag and drop. And then they are not necessarily easily scalable or have good, let's say, permission kind of schema and propagation. Databricks are trying to do something in that area. Synapse are trying to do something in that area. Azure Data Factory is just an ELT tool or orchestration tool, so I'm not going to discuss permissions there. You either have full permissions or you don't have any permissions there. and mostly on the sources that you read and write to, not necessarily the data factory instance itself. So what if I'm a user and I have a self-service pattern that I want to satisfy? I want to import it, I want to create my Power BI report, or I have a Dynamics 365 or a Power App that I want to hook up to that data. What do I do? Well, this is where the common data model and Microsoft Dataverse come in place. So this pattern here that you see is the most common data lakehouse pattern at this point. But it has limitations, mostly around scalability for end users. You have to be highly skillful to work in those environments. Yeah, you may say, okay, but I'm a data analyst or I'm a user, I should be able to write a select star. Well, yeah, but then how many scenarios you will satisfy with just a select star kind of workload or reports? You have to start joining, then you have start having issues with performance, then you have to get into discussions with your data engineering or data architect team or performance tuners that will have to go in and redesign things, and it's gonna end up pretty much in the same pattern as the data warehouse. So you have to have some kind of a low-code representation. And this is where the common data model and Microsoft Dataverse come in. So what is a Microsoft Dataverse? Microsoft Dataverse is a new storage system that is basically aiming to store common data model type of entities and information, and can serve as a storage and communication point for applications like Dynamics 365, like Power Apps. Most of there are use cases with Power BI, and so on and so forth. But under the hood, Microsoft Dataverse is using the common data model. The common data model gives you this governance and management angle on top of what you already have. And I'm going to stress here on the metadata part. What is the common data model? I have a couple of slides. Yeah, let me actually go to the common data model. We have enough time. So what is the common data model? It's a shared data language to use. It's a data definition kind of language. It's based on files and JSON representation of and description of what kind of entities you have. So for instance, I'll just give you an example here. You have a data flow, a folder called data flow. Please don't relate that to a Power BI data flow, just not yet. So imagine that this is a database. That database is fully described in something like a schema file called model.json. The model.json contains, it's a JSON file, obviously, that contains description of the application, of the entities, of the attributes of each of the entities. Entity is a table. And then in that, the attributes, the data type of those attributes, and some additional attributes of those fields. And each of those entities or tables are stored as separate folders, and they can be also stored as either CSV or Parquet format. So imagine that you just have your traditional data lake, but on top of that, you just restructure it a bit and provide a model.json file. You automatically have a schema that you can use, and that schema is shareable across multiple different services. This model.json is used by any common data model service that compatible platform. In Microsoft's case, this is Dynamics 365, it's Power Apps, it's the Azure Data Factory. I'm not sure about Databricks, to be honest. I forgot to check. But Azure Synapse Analytics, Power BI, I don't know if I mentioned it. Power BI data flows are entirely stored as CDM in CDM format. So imagine that. I'm going to go back to here that you have a data lakehouse, and you're doing all your ELTs and ETLs, and you mash up your data and store your data. It's streaming, it's batch, it's all of those things. It's stored in a common data model. If you store it as a common data model, you will automatically be able to hook it up to Azure Machine Learning Services, Power BI, Power Apps, and Microsoft Dynamics 365. So on this side here, you have Spark-based tools, Synapse, Databricks, Azure Data Factory that allow you really high code type of workload management and work with your data. On the right-hand side, you have all those low-code type of tools, which allow basically usage of your data in a drag-and-drop type of manner. And using data lakehouse to have consistent data management and data governance that supports also streaming and batch and updates, deletes, inserts. Combined with the common data model, you're practically covering the end-to-end pattern in an organization for low-code users, like business users, self-service type of provisioning usage pattern, and then all the high code where you need customization and all those things. So let's say that I convinced you that the data lakehouse is the future, and you want to get to a data lakehouse pattern. What are the ways to do that? I combined 3 of the most common tasks from my perspective and my angle, not necessarily yours, or that they don't necessarily apply to all the users out there, but from my personal perspective. So what is the first task you will most probably need to do whenever you decide to go to a data lakehouse pattern? First, you will have to have your data lake into a Delta format. So how to do that? First, you will need obviously Azure Storage Account Generation 2, and most probably Data Factory or Databricks to do the actual computation. I've not explored the Synapse Analytics, but for the sake of the conversation, let's say that it can do that as well, because under the hood it's Spark-based. So for new entities, how do you create a new entity that is in Delta format? Well, it's fairly straightforward. You create a data frame in Spark or in Python. You point to the original data, and then you just write that data in the new format. It's just a syntax. You don't have to do anything. If you have existing data, you have 2 different options. You can convert the existing Parquet files to Delta format using this line here, or you can convert a table, Delta table, that you created in Spark SQL. So you create a table that points to original Parquet, not in Delta format, and then just convert it. What this will do, it will practically create additional set of files and some metadata files that will track historical changes, that will also allow you to read and time travel, read historical data, do time travel for your queries, and you will be able to create those inserts, updates, deletes that we mentioned. I think I lost my train of thought. I wanted to say something else on that topic, but all right, let's switch to the next one. So as a summary to task number 1, if you have existing data lake, it's fairly straightforward to migrate to Delta Lake format. So you just have to use either Spark or Spark SQL to do the transformation. Task number 2. Okay, I have a data factory. I'm a Microsoft-based shop, or my cloud is some of the data workloads are in Azure Data Factory. What do I do? So, if you want to support Delta, to be able to read and write Delta format, you need to use an inline type of data set. So this is a property of your source or destination, which you need to set to be an inline one. The difference between data sets and the inline source type data set is the following. The data set is an object that is being stored in the data factory, and it may or may not have the schema of that data, but it's fixed, it's stored, and it's shareable across other entities, across other flows. This is, by the way, mapping flow. Copy activities do not support this. Mapping workflows are the only ones that support inline source types and Delta format, which you should be careful with, because this will, if you're used to do copy activities and now you want to switch to mapping workflows, it might, or it will most probably increase the cost of your ELT of your ELT jobs. So let's get back to the source settings. So the data set, it was shareable, it has a structure, it has a definition, and so on. The inline source type is something that you define just for this particular mapping workflow. You can't reuse it at all. When you choose inline here, then the dataset type, you will get in Azure Data Factory a bunch of options. So one of them will be Delta, but also you have HBase, you have a common data service, you have Parquet files. So you have a bunch of other inline dataset types that you can use. In our case, for Delta usage, you use the inline dataset type called Delta. When you have this, by the way, the Delta dataset type, you will automatically have schema schema support and schema. How to say it? Well, you can evolve your schema on the fly. So imagine that you read source of data, and that source of data somehow received the files that you started receiving. They have a new column that you never had before. And you want to have this column automatically in your Delta Lake, in your lake house. If you use Delta, this is originally and natively supported by the Delta format. The new column will just be added to the data set. Yes, all previous versions will have this column with the column empty. Only the new ones will have the value, but it will be happening automatically. Of course, you can turn that kind of behavior off. You can change it if you want to have a strict schema conformance, but it's really going to depend on the scenario. So you're using inline, you're using Delta format. And one specific thing, if you want to write to Delta format and support inserts, updates, and support actually updates, deletes, or upserts, you need to add, let me delete all those things because they're still here. I apologize. All right, if you need to write data, so in our sync, in order to support Delta updates, deletes, and upserts, you need to have an outer row modification. Outer row type of transformation is a transformation in Data Factory where you define for which are the rows from the incoming stream that so you have to capture which are the changed rows. Basically, you define the expression which will capture what has been updated or what has been deleted. This is why you use it. This is why you need to have this before the sync. This is the second pattern, and the second task that most probably you'll end up doing within building your first data lakehouse. And the third part is, okay, so I will want to use the CDM format. I will have to use Power BI. And I want to automatically get whatever I have as a data available in my lake hooked up to my Power BI so that can users do reports. Now, this thing is supported in two different ways. Option number one, in Power BI, you can attach your storage account, which your data lake, to either a workspace or to the entire tenant level. And when you do that, you'll be able to create a Power BI data flow. That Power BI data flow is Power Query Online. And that particular data flow will be storing the data in that folder where you pointed. So if you're going to do a huge, let's say, transformation and some kind of a machine learning algorithm on top of your data, you want to place it in a data lakehouse. You want to make sure you use Databricks or machine learning services to do the whole ML thing and prediction or whatever, scoring that you need to do. So this is one of the workloads. And the second part, because the data is sitting in the data lake in a CDM format, you can have a data flow that you use that very same data without doing any copies of that data, straightforward for reporting. Yes, you have to create a data set on top, but having the data lake in a CDM format, you can hook up all those services without making data copies. If you don't use this, you can still use the CDM format folder. You can still do that. But in that case, you have to read that using the Power BI connector for Azure Data Lake Store. With Azure Data Lake Store connector, you can read a single file or a CDM folder. And what you will set up in this case is practically the particular data set will read the data from that CDM folder every time you need to refresh, and it will cache it as a data set. There is no direct query, so it's going to be a cached type of pattern. The same is with the storage attachment, but the huge difference here is that the schema with the first kind of pattern is automatically maintained. If you add new kind of new fields or new folder or new attributes or change data, you will have to change also your data set more or less. Okay, so that's the third most common pattern that potentially you would have, how to hook up Power BI. If we need to talk about Power Apps or Dynamics 365 or something like that, well, in this case, you will need a Dataverse service. In the Dataverse service, you'll be able to either export or import entities that are in CDM format. If you don't have them in CDM format, you have to set up an ELT job. Additional kind of data movement and data engineering in order to get things into the Dataverse format. So keep that in mind. And with 4 minutes left, I don't think I have anything else to share at this point with you. Let me see if there are any questions at this point. Nope, I can't see any questions. So, all right. Then that's all from me. Thank you very much. Enjoy the last session of the day. And I hope to have our next either Global Azure Bootcamp or any other event in person. I know it's kind of strange. Probably it's more comfortable for you to do this online, but honestly, I'm kind of missing the interaction, and it's kind of crazy for me to look just at the screen without seeing a reaction. So anyway, thank you very much. If you have any questions, these are my contacts. Connect with me and I'll be happy to discuss. And before I disconnect, again, I'd like to say thank you to the sponsors. This event couldn't be happening without them. You can see so many sponsors in here. I'm really happy. And enjoy the rest of the day. Thanks.
These days, if you don't have an app, you are falling behind. If you are not using your data, your competition is making better decisions. If you are not automating, your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that you could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there is a partner. Set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days, sun rays. I tap the phone, coffee's on. I mow the lawn, impressing Sean. So connected, so effective. I let it drop, clean it up. Heat and smart, I do my part. Get in the car. Superstar, I check my stock. I'm on. Oven's on. Coming home. All me. IoT. 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 Like a brush. Any connect solutions for a smarter from Bosch.
Datavard is a global software engineering firm that takes a uniquely human approach to solving problems. With over 20 years of experience, teams of highly trained engineers around the world, deep industry sector knowledge, and ongoing technology research, we help clients create custom software that improves their operations and opens new markets. We integrate our engineering excellence with deeply human values that drive our business and our approach to relationships. Curiosity, empathy, trust, honesty, and intuition.
Hold up.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
I'm on. Awesome. Welcome to Global Azure. I'm so excited I get to present here today, and I'm so glad that you're joining us. This is making Kubernetes how we build things. Here is my one and only slide, Notepad. That's all. There are no slides in this talk, only live demos. We're going to look at a lot of tools that help us to build with Kubernetes. Let me show you a little bit about myself. I am Rob Richardson, and you can come to robrich.org, click on presentations, and you'll see the content for this presentation. Now, because there's no slides, there's no content, but click here on About Me, and you'll see some of the things that I've done recently. I'm a Microsoft MVP, a friend of Redgate. AZ Give Camp is really fun. AZ Give Camp brings volunteer developers together with charities to build free software. We start building Friday after work. Sunday afternoon, we deliver that completed software back to the charities. Sleep is optional, caffeine provided. If you're in Phoenix, come join us for the next AZ Give Camp. Or if you'd like a Give Camp here in Sofia or wherever you're connecting from, hit me up on email or on Twitter, and let's get a Give Camp installed in your neighborhood too. Some of the other things that I've done, SQL Source Control Basics, mine is Chapter 8. That was fun to build. And I replied to a .NET Rocks podcast episode. They read my comment on the air, and they sent me a mug. Woohoo! So there's my claim to fame, my .NET Rocks mug. So let's dig into mechanisms where we can use Kubernetes. Now I have here a folder where I just have empty content. Let's dig into mechanisms where we can use Kubernetes in interesting ways. Well, to start off, we can just turn on Kubernetes mode inside Docker Desktop. We just go into the settings and we turn on Enable Kubernetes. But what if we want more control over Kubernetes? What if we want a different version of Kubernetes? That's where Minikube is really helpful. Minikube allows us to run a particular version of Kubernetes and keep more current with Kubernetes versions, or be able to run in nested virtualization a lot easier than with Docker Desktop. Now, once we say Minikube start, it spins up a little virtual machine. So here's my virtual machine running Minikube, and now I can interact with it in the normal way. I start off saying Minikube docker env, and it will spit out the Docker variables that I need, the environment variables, to be able to connect Docker up to this alternate Docker runtime. Now, in this case, I passed in PowerShell, so I got PowerShell variables. But if I'm in a command prompt, I can get command prompt variables. And now once I've applied those variables into place, now Docker image list, I have the normal content. I'm right here in Docker. That's great. Minikube is a great way to be able to run Kubernetes differently. Now, I can run Kubernetes, but I can also run Docker. Let's actually look at one mechanism where we have this Docker file. Here's this Docker file, and it runs this web server. Now, I can start off and I can say, Docker build, I've forgotten what the arguments are. There's a -t, I think. And then why do I need this trailing dot? Okay, so once I've built it, now I can say Docker run. I think I need a -p. Do I need a -e? All of this knowledge is taking up space in my head. And I really wish that I could, well, encapsulate that in a central place. So I start crafting a shell script, but instead, we can use a Docker Compose file. Now, you may have been using Docker Compose forever, in which case this is old hat. But let me show you one new trick here inside this Docker Compose file. Inside this Docker Compose file, we actually have this network mode of bridge. By default, a Docker Compose file will create an overlay network that isolates all of these services from other services on my machine. But in this case, I don't want to do that. I want to leave it open. Now I can launch multiple Docker files, and each of those services can interact with each other. That's great. So let's do that. Docker Compose up. And now as my website is running, I can come back to my machine and refresh my app. There we go. Hello world. That's the website that I was looking for, and proving that this is live. Path to node, and we still get hello world. Now, why did I choose Minikube 3000 here instead of localhost 3000? Well, that's the nature of Minikube. When I spin up into a separate virtual machine, I now have the ability to be able to reference that not just by localhost, like I do with Docker, making all of the other things conflict. Docker desktop, if you're running IIS locally and you want to run Nginx, because I'm running on Minikube, I have a separate IP address for that Minikube VM. Now, Minikube definitely is the batteries included version, but it doesn't do as much auto magic things. So if I want to map a volume, I need to first map it from my machine into the VM to be able to map from the VM into my container. Similarly, if I want to map a port, I don't just go to localhost, I go to Minikube : that port number. Now, all else being equal, I find that really freeing. Let's take down this Docker compose file. Docker compose down. Oh, we're stopping this container. Here we go. Docker compose down. Docker container list. And I see that my container is down. Ooh, but I do see a bunch of other things. By default, inside the Docker settings for Kubernetes, it hides all of the system containers. In Minikube, by default, it does not. That's kind of cool. I get to see my content. Okay, so let me say Docker container list, but let me pipe that to grep-v k8s. I noticed that all of my pods have k8s in the name. So I'll just grep-v for k8s, and here's all of my containers. That's cool. So first stop in our tour of cool tools for using containers in development is Minikube. Minikube allows us to run containers in nested virtualization or to run containers with a much more modern version of Kubernetes than available in Docker Desktop, and gives us a little bit more control and visibility into it. That was cool. If we're on Linux, we might choose to use micro k8s or K3s. If we're on Windows or Mac, then Minikube is a really elegant mechanism. Kind is another mechanism that allows us to run Kubernetes inside of Docker. It makes the Kubernetes nodes Docker containers, but now we have double nested virtualization. Yeah, Docker in Docker is interesting, and Kubernetes in Docker is interesting as well. I tend to prefer Minikube or K3s though. Okay, so now that I'm inside of this environment, let's look at another tool. Now, ideally, I would say Docker watch something. Now, Docker watch is not a thing, but what do I do if I want to rebuild my containers whenever my code changes? Let's take a look at a tool called Scaffold. Now, I start off with Scaffold here. Scaffold is a tool that allows me to watch my containers and watch my source code. And whenever a source code change happens, it will automatically rebuild my containers. It can optionally push them to a container registry and then ultimately start those containers on a Kubernetes cluster. So we can see in this animation, the first stop is to do a scaffold init. And I've already done that in this case. I have here a scaffold.yaml file. Do I need to reshare my desktop? That was a little weird. I think my machine froze for a bit, but I'm glad we're back. Let's dig in now to Scaffold and Docker Watch. So we looked at a mechanism where we really want to be able to watch our source code, and whenever our source code changes, we want to rebuild our image. So I have here a Scaffold YAML file, and this Scaffold YAML file describes all of the pieces that I need to be able to run my system. Now it says, here's the Docker file that I want to build, this hello node image. Here's the Kubernetes YAML file that I need to be able to do that content. And so now here on my command line, I will say scaffold dev. Now, when I say scaffold dev, it's going to sit here and rebuild my image whenever my source code changes. So here I'm going to make a change in my application. Hello, global Azure. And we see that automatically Scaffold is going to notice that code change and rebuild my image. Ooh, it just found a change. It's rerunning the Docker build, and it's rerunning the kubectl apply. That's really cool. So now that my system is ready, my container is running on localhost 3000. Let's see where it's running inside of Kubernetes right here. So I can now go to my that's interesting. It closed one of my tab groups. So I can come to minikube : that port, and I will now see my website running. That is great. So we were able to use Scaffold to be able to automatically rebuild content whenever my content changes. Very nice. Let me hit Control-C here and stop that auto rebuild. And kubectl get all. Let's see if it pulled it down. It's terminating. That is perfect. Next up, let's look at a tool for being able to visualize our cluster. We can look at Dive. Dive is a really elegant mechanism for being able to see inside containers. Now, I can look at each of the layers inside of a container, and I can traverse all of the pieces around that container, all the files at that level. So let's come in here and we will say Dive. So I have Docker history, hello node. And I can see all of the layers, all of the commands that were built, but I can't see into the files. Let's say dive hello node v0.1. And now I can start to look into the particulars of this image. Now, it will take a little bit to pull that image from my Docker registry into Dive. But once I'm inside Dive, I have this really elegant experience where now I can wander up and down through the layers. If I hit Tab, now I can come in through the folders. Well, I'm going to hide these folders. And hitting Tab again, let's move up through the layers. So on this layer, I got all of these green files. On this layer, here's where my app starts. So let's come up to here and I'll open up the app folder. Well, right now it's empty. Now I go down a layer and I can see that it copied in the server.js, which I expected, but it also copied in my Docker Compose and my Docker file. It seems like I need to adjust my .docker ignore to be able to better utilize my system. I probably don't need to copy in these extra pieces. Now that's something that's difficult to visualize when I'm just looking at the Docker history. That's really cool. I can also see the hashes of each command. I can also see the command itself. But the really fun part about Dive is being able to look at the contents in each layer. I can also see the total image size based on that. Cool. So Dive was a really elegant mechanism for us to visualize the contents of a cluster. Very nice. Docker container prune. Let's remove some extra containers. Now let's look at mechanisms where we can administer our cluster. So we can look at lazy Docker. Lazy Docker is a command line mechanism for being able to visualize the details of our cluster. And it's a really elegant mechanism because, for example, I can click on things in my console. That is amazing. Let's do that. Lazy Docker. Would you like to enable anonymous reporting? Sure. So now I can take a look at my containers. Now, my thing has been running for, I don't know, not very long so far, but let's pick a container and now we can move through the things. I've noticed that in Windows, clicking on a console doesn't work real great, but I love the ability to visualize here with Lazy Docker. It's really elegant. If we wanted to take that to the next level, we can look at a tool like Portainer. Here is Portainer, and Portainer is really interesting in that we can start to visualize the details in our cluster in a very visual way. Portainer, the community edition is completely free, and so now we can look at all of the details. Now, one of the things that Portainer does really well, let's go grab this, is they provide a Docker Compose file that allows us to really easily spin up Portainer. Here's that Docker Compose file, and we can then launch that Docker Compose and do really interesting things. So let's launch Docker Compose. There we go. Docker Compose up. And let's launch Portainer. Now, there is a mechanism to launch Portainer in Kubernetes mode, and that is interesting as well. But in this case, we'll just launch it in Docker mode. So let's go to port 9000. Now, I am using Minikube. So when I come to Minikube:9000, now I load Portainer. Now, the interesting thing about Portainer is I haven't logged in yet. So let me create a password. Password. And let's create user. Now with Portainer, I could manage a remote environment like my environment up on Azure or another cloud. I could go to an on-prem system. In my case, I want to manage the local Docker environment. Now it tells me that I need to map in the Docker sock, and good thing that the Portainer YAML already does that. So that's not it. This one. We've already got the Docker sock mapped in, so we can get at our Portainer cluster. Yep, let's connect. And now we can see all of the content in our system. Let's look at our local environment. Now I do have 28 images. I've got quite a lot running. That's cool. How many containers do I have running? I've got all the containers associated with Kubernetes running. But let's also start the node app. Docker image list. Hello node. Docker run -p 3000. Hello node. Oh, 0.1. Now that I've got this image running, let's come back to Portainer and take a look at the content here in our clusters. Refresh, and now here's that hello node container. I can see the published ports associated with it, and I can see the image, all of the details that I was able to get from the command line, I can see here in Portainer as well. Clicking into it, I can take a look at all of the pieces in here, and I can take a look at the Docker logs. In this case, there aren't very many logs. That's totally fine. But I can also take a step back and take a look at the console. Now, in this case, it's a Alpine container, so I'll use ash instead of bash, and I will connect. Now, I am inside that container. Let's cat server.js. There's my server.js file, and cat docker file. I can interact with my app through the console through this website. Let's exit out of that, and we're back to our system. Now, if we get to a point where we're like, I need to remove that container, let's remove it. Yes, I'm going to remove it. Do I want to also remove volumes? Nope, I will leave that in place. Portainer is a great way to visualize the Docker ecosystem and get a feel for my cluster. Containers, volumes, networks. Ooh, I didn't realize I had so many volumes. That's cool. I love to be able to wander through Portainer because it's really, really fun. Okay, so let's stop Portainer. Docker compose down. Now we looked at Minikube, an alternate runtime environment, and the beauty of Minikube is it not only gives us an alternate Docker runtime, but it also gives us an alternate Kubernetes runtime. Let's take a look at that Kubernetes system. Now inside of Minikube, we can do kubectl get all, and we get all of the normal details of Kubernetes. Kubectl get nodes, kubectl get, well, I'd like to be able to visualize this in a visual way as well. So let's do a kubectl apply -f k8 dash. K8 dash is a really elegant mechanism for visualizing Kubernetes dashboards, or visualizing Kubernetes. Here with K8 dash, I have a view of my Kubernetes cluster with all of the things detailed in my Kubernetes cluster. So let's take a look at where it started. kubectl get all. It looks like that started K8 dash on port 31150. Cool. So let's come here to Minikube 31150. And now we're asked to enter our auth token. Now I can go get that token by saying kubectl get secrets. Here's that token that was created as I spun up the Kubernetes dash the first time. And now I can say kubectl describe secret K8 dash, go get that token. And here's my auth token that I need to be able to log in. Now this one is local on my machine, so I'm not super worried about exposing it, but yes, you definitely don't want to expose that secret on, say, a live share like this. Now that I'm in my Kubernetes dashboard, now I can take a look around inside Kubernetes. Now this is a one node cluster, so I only have a single node, but I can take a look around inside my workloads. Let's look at the pods that are running. Workloads, pods. Here's all the pods doing the things. Now, in this case, they're all in a particular namespace, so I can filter down to, here's the K8s- running in the default namespace. Let's take a look at that pod. Here's the pod details. Now, it hasn't been running for a very long time, but here's the events associated with it and all the particular details I need about that pod. I can flip over to look at the services. Here's the K-service and both the private and public ports. It's of type node port. I'm not seeing the node port though, and that's interesting. One of the things that I like looking at here inside K8s- storage, volumes. I don't have any volumes, but let's look at accounts, secrets. Now, by default, when I say kubectl get all, I don't get secrets in this list. How many secrets do I have? K8s- makes that, or K8- makes that really easy to visualize. Yeah, I have a lot. Did you mean to have this many secrets baked into your system? Well, let's look at the K8- token as an example of a secret. Here's that token. I love that it's blurred by default, but I can unlock that and I can get at those details. It looks like it's a JWT token with the dots there. That's cool. So I can use K8- to visualize my Kubernetes cluster, and I can use Portainer to visualize my Docker cluster. Now, in this case, they're the same, but I love how the K8- really focuses on the Kubernetes pieces, while Portainer really focuses on the Docker view of things. So that was really cool. Let's kubectl delete -f K8- kubectl get all, and it looks like that's coming down. Very nice. So the next tool that I want to show you is debugging inside of containers. Now, to do this, we will look at Visual Studio Code. Visual Studio Code has a rich ecosystem of plugins, and I love the details associated with this to make it really elegant. Now, in this case, when we're debugging, we're going to split Visual Studio in half. Half of it will be focused on our user experience, our UI, and we'll have themes and other extensions here. Half of it will be inside the container where we focus on building our content. Now, here we'll have plugins associated with language services and build tools. And then we'll have a WebSocket port that allows us to connect into that container to work there. A volume similarly allows us to connect into that content. Now, this being Minikube, I did need to connect my machine up to a volume. So I did a Minikube mount and I set that content into place. But now here in VS Code, we can take a look at the content associated with that piece. Oh, actually, before we go there, let's look at mechanisms, other mechanisms inside of VS Code to be able to see stuff. Now, I've chosen to install the Docker plugin, and the Docker plugin allows us to see the containers, the images, if you wanted to connect a registry, the networks, and so I can see all of the pieces that I have. I have a volume left over from Portainer. If I come in here and I say, Docker run that hello node container again, coming back here into VS Code, I'll be able to see that container start up right there. Now, the cool thing here about this container is not only can I see the container itself, but I can also visualize the files within that container. We use dive for this from the command line, but it's really elegant to be able to do this from within VS Code as well. Now, it looks like I'm having difficulty execing into that container. That's fine. By comparison, I've also got the Kubernetes plugin, and this allows me to view my cluster from the Kubernetes mode. Now, it does look for Helm repos, and I can log into other Kubernetes clusters, and that's really elegant. Well, by default, it's going to look into the Docker desktop Docker registry, and I really wanted to point it at a different registry instead. So I came in here to my settings, Control-Shift-P opens up the settings, and I'm going to open up the settings JSON file. Now I've specified here the Docker host. Here's the IP address of my Minikube cluster. So I came in here and I said Minikube IP, and that got me the IP address of Minikube, and I set that in place. This is also the cert path that Minikube gave me for my certificate, so that now VS Code knows how to connect into my Minikube cluster as well. Once I've got those environment variables set, now I can wander through my cluster and take a look at that content. Here's my namespaces, and I have default together with some other ones. What workloads am I running? Well, here's the deployments, and nothing in my default namespace. Pods, I've only got the Kubernetes service in my default namespace, but let me start this node back up. Oh, it's still running. Oh, because it's not running as a Kubernetes pod, it's just running as a Docker container. So I won't be able to see that there. I love that I can visualize here inside of VS Code. That is really cool. Let's launch VS Code inside this debugging folder and take a look at the content that we can use inside of VS Code to debug inside of a container. So I'm going to open up this folder with code, and I have the code remoting extensions installed. Let's go look at the remoting extensions. I came in here and I said remoting. Now, why is it called the remoting extensions? Remote. There we go. The remote extensions. Now there's a containers extension. There's a remote WSL extension. There's a remote SSH extension. And each of those allow you to connect to a different source and be able to run the content within that source. Now, in my case, I grabbed the remote development extension, which includes all three of those. Because I now have all three of these installed, including the remote containers extension, I now have the ability to run remote containers. Now, this is really cool. I can come in here to this green dot, and I pop it open. And if I want to get started with remote containers, I can say try a sample. When I try a sample, I can pick from various languages: Node, Python, PHP, .NET Core. If I were to choose this, it would automatically spin up a project that had all of the details associated with doing VS Code remoting into containers, and it would bake all that into place. Now, I've already done that in this case. I already have a project running, but I could do a similar thing where I could say, add development container configuration files. Now, when I choose this, it tells me they're already there. It will actually walk me through the process of building out this content. Let's take a look at what we have. We have a .dev container file, a dev container folder, and inside there we have a dev container.json file. This dev container.json file details all of the details that we need to be able to spin up our content inside of VS Code. What is my Docker file? Now, in this case, this is a Docker file, and it's a pretty standard Docker file. I chose to add curl into this container in case I want to do some Git content inside of that container. But ultimately, it's a pretty standard Docker file. After that Docker file runs, I'm going to run npm install. Now, npm install gets all the content for my content. I could choose to run a .NET container instead, in which case I would say .NET restore. I can also choose settings for my editor. I have forwarded ports. In this case, port 3000 is the one that I'll debug from when I'm inside Node. And because I'm inside of Minikube, I can bind mount my content. Now, I do need to Minikube mount my desktop into the Minikube VM, But once I've done that, then I can spin it up. So it popped up straight away saying, hey, can I launch in a container? And I didn't click it at the time, but let's do that now. Reopen in container. Now, when we reopen in container, it will restart our application or restart our VS Code session, splitting it in half. And I love to watch it go because these are actual Docker commands doing the thing. Let me go see if I have a container running. Nope, I don't. Let me start up a new one. Here's that Docker run command, getting all of the things in place, mapping in my volumes, make sure it works. And it's splitting now VS Code into two pieces. The first piece is running on my desktop, and it has all of the themes and UI experience, my font choice. The other part is running in a container, and that container is running, in this case, the Node debug environment. So now I'm running in the container. It's spinning up. Ooh, it looks like I have a new version of NPM available. That's pretty cool. Now this is real live Docker, and I'm really inside the container. Uname -a, I'm inside Linux. If I come here and I say Docker container list, and I'm going to pipe it to grep-v k8s so that I exclude the node services, I see my hello node container running on port 3000, and I see this other container that I've got debugging. Well, let's take down the Docker container rm-f c36. Let's take down that other container just in case we're conflicting with port 3000. And now I'm here running inside this container. Now, the cool part about being inside of a container is I didn't need to install Node on my machine. I just spun up a container and did all the things. But one of the things that I really, really love about debugging is setting breakpoints. So let's set some breakpoints for this content running in the container. And now I'm going to come in here to my debugger, and I'm going to start debugging. Now, I chose to forward port 3000 from my local machine into the container, but it's really good at noticing, hey, do you want to open a browser? Why, yes, I do. And we can see that we already hit our first breakpoint. Server is running at, and let me turn off that breakpoint and push go. Here's my console output. Server is running at 3000, and straight away my browser hits. I can take a look at the request and response, much like I would with any other debugging mechanism. I have all of the content available for my content inside of VS Code, where I can go wander through all the variables as well. Now I'm going to push play, and I hit the request for favicon.ico, and I will push play again. And here's my website running inside of my container. So if ever you wanted to debug a container in the middle of a request stream, and it's like, but I just need to be able to set a breakpoint there in the middle, that's where VS Code remoting is really, really helpful. Here's my breakpoint, and I'm ready to go. Now, one of the things that's interesting is that I chose to port forward. So instead of going to minikube:3000, I'm actually going to localhost 3000. If I was doing VS Code remote in containers on a cluster, say in Azure, it would be able to automatically securely proxy me into there, and I would still run from localhost and that particular port. So I've been able to debug my application inside the container. It's working out real well. And now when I'm done, I can say dev container, I would like to close remote connection. And I've just closed that container, and I'm back into my regular VS Code. Now, the cool part here is that we were able to see mechanisms for being able to debug in containers, to visualize our cluster either from the command line or from UI tools, either in Docker mode or in Kubernetes mode. We're able to start our system differently, running inside Minikube, where we could control the Kubernetes version. And we were able to use Docker Compose, where we didn't have to remember all of the pieces. We could just launch it straight away. Scaffold is a great Docker watch, where it'll automatically rebuild and run these things. As we can see, we have lots of tools here inside of our developer environment so that we can build with containers rather than assuming containers get pushed into place with the DevOps pipeline later. It's really fun to build with containers, and here's a bunch of tools that will hopefully get you started. Hopefully that'll get you the search terms where you can discover even more tools to be able to run in really elegant environments. I've had a lot of fun showing you lots of really cool tools here inside of Kubernetes and Docker. If you're watching this session later and want to hit me up with questions or comments, a tool I didn't mention or one that you're really excited about, hit me up on Twitter at Rob_Rich. For those who are watching live today, what are your questions? One of the questions I often get is this Azure specific? All the tools that we looked at today work equally on any cloud, whether it's Azure or AWS or GCP or even your on-prem cluster. These tools will work great in any environment. They're Kubernetes and Docker tools, not cloud-specific tools. We've got 15 minutes more for the questions. That is really cool. I was expecting that we would have lots of questions, but we don't. So let's dig into a few more things. One of the things that's really cool about Minikube is that ability to upgrade to different versions of Kubernetes. Now, in this case, kubectl version. In this case, I'm running Kubernetes version 120. And that's really, really cool. As we start up Minikube, we can say Minikube start, and then we can say -- version. And in my case, I said stable, which gets me 1.20. But we could also say a particular version equals 1.18, or being able to really dive into that specific version is really elegant. Another thing that we can do is we can have specific clusters for interesting things. As I do a demo about Istio and Linkerd, I want to be able to demo both Istio and Linkerd, but I don't want them necessarily running on the same cluster. So I have an Istio cluster. So as I start up my cluster, I now have two different clusters. One that is my default Minikube cluster and one that is very specific to Istio. Minikube really allows me to separate those pieces in really elegant ways. And at the end of the day, I just end up with multiple VMs here to be able to accomplish each of those tasks. Minikube is really cool. One of the things that we looked at with Docker Compose, let's pop open that Docker Compose file again. Docker Compose by default will create unique networks. Now, in this case, I wanted to disable that network. So I said network mode is bridge. Now, when I say network mode as bridge, then it won't create an overlay network. It will just use the built-in Docker network. That means that I can launch multiple Docker Compose files. So, for example, I can say Docker Compose up -f Docker Compose dependencies or databases .yaml. So let's spin up all of those dependencies. We'll spin up SQL Server or Redis or SingleStore, and we'll get all of those dependencies in place. And now usually it's like, well, how do I attach to that network? When I say network mode is bridge, then I don't need to join that network because all of them are still in place. Next up, I can say docker compose up -f backend.yaml. Now I'm spinning up all of the APIs and all of the other resources that I don't need because maybe in this case, I'm focusing on the front end. Docker compose up -f frontend.yaml. I was able to spin up multiple Docker compose files, and they're now all able to interact in really elegant ways. The really cool part here is that because I didn't create a new network, it didn't lock those things apart. That's one of the biggest downsides to a Docker compose file is that it creates the network. So we end up stringing together Docker run commands in a run.sh type of thing. By specifying this network mode is bridge, then we eliminate that need completely. Another thing that we saw was scaffold. And I really wish that there was a, this demo may have gotten cut off when the machine froze, but scaffold is really elegant at being able to do kind of a Docker watch type of thing. Now we have a node watch, our npm watch. We have a .NET watch, but there's not really a thing of Docker watch. Instead, we can use scaffold. So I start off by saying scaffold init, and it will scaffold out a YAML file that describes all of the pieces that we need to be able to watch our code and run. In this case, I already have a scaffold YAML file. It's here where I have the metadata associated with that content, the image name that I want to build, and the Kubernetes manifest that I want to run. So whenever any code changes in here, it'll automatically do this Docker rebuild and automatically do this Kubernetes apply. So let's do that. CLS scaffold dev. And now it's going to sit here and it's going to watch the file. And whenever that file has changes, it will now rebuild the content. This is cool. So I can come back in here to my server, and instead here of hello global Azure, hello world. Now I hit save, automatically it notices that code changed, it rebuilt my container, and it pushed it up to my cluster. Now in this case, my container, my Docker build system and my container runtime system are the same thing, so I didn't need to deploy it anywhere, but I was automatically able to kick that off. And now if I come here to Minikube 3000, I get my new content straight away. Oh, I'm running on the wrong port. Let me go look at that again. kubectl get all. I need to go grab the node port for this. Scaffold, there we go. Now, sometimes it's easier just to Docker watch locally, and that's where things like Project Ty might come into place. But it's also really helpful to be able to quickly rebuild and refresh inside containers. And Scaffold is the perfect tool to be able to accomplish that. Scaffold makes debugging super easy. Lazy Docker was one that we looked at, and we looked at it super fast in hindsight. Let's dig in a little bit more. And let's look, oh, not there. Lazy Docker. Here we go. Lazy Docker. I love that you can click inside of a console. Windows consoles don't click very much, but ooh, I've got an exited container. Let's take a look at why that container exited. Nope. It looks like Portainer might be a better choice for visualizing this. Let's go fire up Portainer and see why we've got that exited. Docker compose up. There we go, Portainer. Minikube 9000. I will log in with my password that I set previously. Look at my local development environment. Let's connect. Containers, which one just exited? There we go, sweet Lamport. The logs. Container started. Okay, that wasn't the reason. I do see, though, that this container is based on, where did that go? Back in my container list. I see that this container is based on the VS Code debugging base image. So I'm guessing once I closed that image, it stopped it, but it didn't remove it. Okay, that's easy enough. Let's remove this. Now, do we also want to remove the persistent volumes? I did notice that while we were here, Docker volume list, we ended up with this VS Code dangling volume. So, why, yes, thank you, Portainer. I would like to remove that volume. Let's remove that volume. And now I'm ready to go. What other volumes are in my system? Now, these two are unused. Let me refresh. I will go prune these. That worked out really well. Thanks, Portainer, for helping me find unused content. Containers. These two are created, but not running correctly. Let me come in here, CLS, Docker system, Docker container, prune -f. Let's see if that deleted those two containers. Refresh. Yes. Oh, one of the things that we looked at with Dive, and we actually didn't solve it, but since we have a minute to solve it, let's do it. We looked at Dive, hello, node, v0.1. Now here inside this image, let me hide the bin folder and the Etsy folder. We were wandering through the layers. And here's where my Docker file starts with the workdir app. And then I have the copy layer, and it copied these files. I have server and Docker compose and Docker file. I probably didn't want all of the rest of that content in place. Now, it's probably because I need to adjust my Docker file or my Docker ignore file. So I'm going to create a new file, .docker ignore. And here in my Docker ignore file, I'm going to ignore Docker file and docker compose.yaml. And because I've got scaffold running, do I still have scaffold running? Nope. Let's come back over here and cd into Docker watch scaffold dev. Oh, that's actually a different folder. Let me come back into one Docker build -t hello node. That's where I was going with that. Now that I've got that container rebuilt, now let's come back in here with Dive and see if I fixed it. I love how these tools are able to interact in really elegant ways together and be able to find the things that we need. So I just created the folder. Now I copy in, I copied in .docker ignore. Okay, so let's tune this to ignore the .docker ignore file 2. That's interesting that I need to ignore the Docker ignore file. I suspect then I need to also ignore git and git ignore and other files like that. That's pretty cool. Okay, one more lap through. Let's Docker build dive hello node. Yeah. Oh, I still have the Docker ignore file. It looks like ignore. Ignore. Did I spell it incorrectly? I bet I did. Yeah, spelling is hard. Docker build dive. And now that is the leanest that I possibly can. Very nice. Total image size is 112 megs. That is beautiful. Try to spin up a virtual machine and get it to be 112 megs. That is really hard. Portainer, k-dive, lazy Docker, scaffold, minikube. These are all tools that help us build with containers, build in context with the containers. And in particular, the VS Code remote extension is so cool in being able to separate these pieces, to be able to step into the debug environment while still being inside of a container. If you've left containers as a runtime concern, as a build time concern, something that the build server just sets into place, I would invite you to look again and see how these things can work together in context. I love to build with containers. I love to build inside containers. I love to debug inside containers and to be able to look around and see how this works. If ever you have a problem that only happens in production but doesn't happen when you're debugging, then being able to step into the container and debug it is magical. Take a look at the layers inside of the container, and you can really tune your system to have a really elegant experience. I had so much fun getting to present today, and I'm glad that we had some additional time to be able to dig deeper into the things. Machine errors notwithstanding, but this is so much fun to be able to join you here on Global Azure. Are there any questions from users here on the stream? No questions. Sounds like we got it solved. Well, if you do find questions tomorrow, or if you'd like to dig deeper into tools, or if there's a tool that I didn't mention that you'd like to bring my attention to, hit me up on Twitter at Rob_Rich, and let's definitely continue this conversation. Thanks everyone for joining us here at Global Azure Bootcamp.
Your work processes are getting outdated. These days, no matter what industry you are in, you need tech R&D to stay relevant. And that wouldn't be a problem if setting it up was easy. Imagine that You could just press a button and have an R&D department spring to life. Imagine that the team already knows each other and works well together. Imagine that ways of work are industry leading, yet the culture is unmistakably your own. Imagine that you have access to an extensive network in an abundant, cost-efficient talent market. Can you imagine how easy scaling would be? Imagine there's a partner that could set it all up for you, operate it until it's up to speed, and then, when you decide, transfer it over to you. A partner that only succeeds when you succeed, that makes costs 100% predictable, gives you access to industry expertise, and makes every aspect of recruitment and HR effortless. Imagine the power of that. At Anthill, we imagined a service that would do all that, and then made it a reality. We think it transforms IT innovation from existential threat to low-hanging fruit, empowering your business to be well-equipped for the age of AI, virtual reality, and the Internet of Things. Learn more at anthill.one.
I start my days like a boss. Sun rays. I tap the phone. Coffee's on. I mow the lawn. And cussing Sean. So connected. So effective. I let it drop. Clean it up. Heat and smart. I do my part. Get in the car. Superstar. They're watching me. IoT. 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 IoT, IoT, I check my stock. What a shock. Buy some prawn. My oven's on. Coming home. Future zone. All for me. IoT, 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 IoT. Live like a Bosch with many connectivity solutions for a smarter future. From Bosch.
Datavard is a global software engineering firm that takes a uniquely human approach to solving problems. With over 20 years of experience, teams of highly trained engineers around the world, deep industry sector knowledge, and ongoing technology research, we help clients create custom software that improves their operations and opens new markets. We integrate our engineering excellence with deeply human values that drive our business and our approach to relationships: curiosity, empathy, trust, honesty, and intuition.
Hold up.
Независимо от работата от разстояние, в MentorMate продължихме да бъдем свързани. Работим от офиса, от вкъщи, от всяка точка на света. Това вече е ежедневие. За да отговорим на нуждите на всеки, създадохме 3 модела на работа, от които всеки в компанията може да избира и след края на пандемията. Първия вариант е комбинация от работа от вкъщи и работа в офиса. Комфортът на собствения ви дом ще бъде съчетан с социалните контакти в офиса. Може да предпочетете да работите изцяло от вкъщи, като ще имате опционално място в офиса след предварителна заявка. Искате изцяло гъвкава и дистанционна работа? Може да работите от всяка точка на света, гарантирайки си по-високи доходи. За да осъществим тези модели на работа, ще инвестираме $1 милион в висококачествено техническо оборудване, което да даде възможност на всеки да работи комфортно, независимо къде се намира. Придобивките за хората в компанията също стават гъвкави, като всеки ще може да избира най-удобните за себе си. Като компания, която цени служителите си, даваме възможност сами да избирате. Тези модели на работа важат за всички отворени позиции и не са ограничени за времето в пандемия. Посетете нашата кариерна страница mentormate.com/bg/careers и вижте отворените ни позиции.
Had a lot of good moments with our technical content, with our speakers and partners. We will provide you also additional interesting information. Just a few minutes ago, one of our partners, Anghil, said that they will have very interesting, cool awards with books. So we will provide you additionally links for Anghil raffle, and if there will be additional presents from our partners, so stay tuned. And I think that you will have many options to have very interesting awards. And we will try to have every month sessions related to cloud data platform and AI, like part of our meetups, and expecting 26th of June when we will have our AI and IoT conference. We work on this conference from several months, and I suppose that it will be great event. We will do the best. We will expect you. If it is possible to join on site, we will do it. In any case, it will be a hybrid event, so we will stream it. But if it is possible, people who want to join on site are welcome. We will have very interesting things. So thank you one time more for joining, and I would like to wish you good evening, and we will meet again no later than at AI and IoT conference.